Quests. If we're making video games, we should probably take a look into how to set up quests. So in this series, we're going to go from nothing to a fully functioning quest system. So what we'll do is we'll make a way to gain quests. So you can see here, we have a quest gained with a lot of objectives, all of which have sub-objectives, and some sub-objectives will unlock when other objectives are done. And part of this will be setting up everything you see on screen right here, right now. Also, one of the important things to go over is if I go into a different level, I can see I still have the quest, but it now has a different objective. That being going to the right level to complete this quest. And inside this level, there's also a possibility to pick up this quest. So quests will persist between levels, but we'll be able to show different objectives depending on what you need in each specific situation. So now if we go back into our original level, we can see we can pick up where we left off. So we also keep persistent track of the progress of each quest. Without further ado, let's jump right into the first part here in constructing this quest system. And we're here in an entirely empty project with no quest system implemented yet. We're going to go through this in about 10 or 11 different videos. Each video is going to, as always, have a Patreon link or a YouTube member link down below in the description to get both the fully completed quest system as well as each individual episode's progress as a download for the project files. This first video is going to contain a lot of setup, a lot of stuff that we need to create in order to actually have the system functioning down the line. So let's get right into that and talk about how we're going to structure these quests. There's 3 different concepts that we're going to need to make. So I'm going to make a folder here for all our quest related stuff. And the first and probably most important one is we're going to be making a blueprint actor, and we'll just call this something like base quest. This is going to hold all of the templates and all of the information on what a quest can do and what a quest can be. And then we'll make a bunch of children of all of this that implement actual individual quests. So for each quest in your game, you're gonna have a separate actor blueprint in order to script out the actual goals and the actual behavior of that quest. Then we're going to make another blueprint class here. And instead of taking one of these, we're going to go into all classes and we're going to select object. We're going to make a just basic U object, and this will be called the base objective. This will allow us to make a bunch of scriptable objectives, such as location events, or maybe kill a certain enemy, or maybe pick up a certain item, or whatever other kind of systems you have in your game. You can hook into these with making a specific type of objective that hooks into any of your other code. If that doesn't fully make sense yet, when we start making the most basic objective we can, which is going to be a location objective, just walking to a place, hopefully the pieces will start falling into place. So to recap real quick, we're going to make each individual quest its own actor. And then each one of those actors is going to have a list of objectives, but the objectives we only need to make a new class for every type of objectives. So if we have 5 location objectives, we don't need to make separate classes for each one of those. Those are all going to function as a child of this base objective. And then, of course, quite relevant as well will be the actor component that will be our quest components. Now, you can just make most of the code that we're going to be making in this quest component directly inside of your player character instead, if you prefer. I like doing things with components to group together all the code that is relevant, and maybe if you end up having different characters, you can easily just apply this component to a different character. Also makes it easier to port something into a different project. And for all of you who want to use this system just from the download, it's easier if there's a component instead of having to resolve conflicts with your own character classes. So these are the 3 things that we're going to go over at a very basic level today. And I think the thing that makes the most sense to start doing will be setting up the quest. So before we do anything else, we want to go into class settings and we want to go into advanced and make sure that we set this as generate abstract class. And if we compile that, we now no longer can put this into the world because it's just an abstract class. we don't want to use the base quest to place into the world anywhere. We're only going to use this to override things for our actual quests at some point down the line. Now, we'll make a new function, and I will call this something like init objectives. And this is going to initialize the objectives for each individual quest. It will have an output, and for the time being, we're just going to make that of type objective, just base objective. In the future, we'll change this around a little bit once we start worrying about like making nested objectives and all that kind of stuff. But for now, we don't actually want to put any code in here. Matter of fact, we don't ever want to run this function. We only make this function so that all the child blueprints can put their own code into this function. So let's put in a print string and say something like parent objective init cold, just to make sure that we understand that it's a bad thing. We also make it a red color, because why not? We never want to run this, is the basic idea. Now, I'm going to go ahead and make a child blueprint of this base quest as an example. So create a child blueprint class. You can also just go into making a blueprint class and look up our base quest and make it of this way. And we'll call this something like test quest. You'll notice that this one, unlike the base quest, which you can't drag into the world, the test quest has no problem being dragged into the world. And here, if we go into functions, we can override the init objectives from the base quest. So this will first call the parent version of the function, which we actually don't want to do. So we'll delete that. And then here we have the room to write out the logic in the objectives for this very specific quest. But in order to do that, we're going to need to set up some objectives and make them work. So let's get into our base objective, and we're gonna put a couple of variables in here before we start with anything else. And those will be a bool for isActive. This is going to be relevant later down the line, but we might as well make them now so that we get all of that out of the way. We also want a isComplete. Both of these mostly serve for visualization purposes, but also can be used to like track whether or not a quest as a whole is completed. Then we get the objective name, which is going to be a text or a string. I'm going to go just for a normal string here. But do keep in mind that this is the name that is going to be displayed to the player. So if you want to localize this in any way, shape or form, you might want to go for a text, because texts allow different language translations to be stored in one variable. For this one, we're going to set it as instance editable, and we're going to expose it on spawn. Next up, we create a objective ID, which will just make a string, which will also be instance editable. You can either do that through this icon or just by setting instance editable to true here. And then we expose this on spawn as well. And lastly, we want to do a show progress bar, which will be a bool and also be instance editable and exposed on spawn. So now when we create an object of this type, we'll be able to just give in these three values as input parameters. We're also going to make two event dispatchers, one to update the objective and one to finish the objective. Because certain logic we want to hook up to whenever any objective gets updated, and other logic we only want to execute when an objective is fully finished. So that's just a lot of variables and a lot of things that we have to set up so that we just have it and we can set it and forget it and we can use them when they actually become relevant. So let's implement a couple of functions here as well. The first of which will be activate objective. And this will quite simply just set the isActive to being true. We don't even need to like put in an input parameter or whatever, because once an objective is set to true, you're probably never going to set it to false again. So this just needs to set it from false to true. And then very similarly, what we can do is we can make a finish objective function here, which will set isComplete to being true, and also will call out the finished event dispatcher that we have. Because if anybody is listening to this specific objective for being finished, this is what we will do. Next up, we'll make another function called getCompletedObjectives. And this is going to have a return type. And the return type is going to be a little bit weird at first, but we'll call this something like completed objectives. And this will actually be a string array. And the reason for that is that once we have this base objective set up, we're going to make something called an objective collection, which is going to be a objective that can house multiple other objectives inside of it. So for this singular objective, we'll just return whether or not this one objective has been completed. But for the sake of ease of use later down the line, we make this in an inheritance hierarchy so that it's all calling the same function, and the objective collection will have a more complex implementation of this specific function. For now though, we simply just check if is complete. So we drag in is complete, we add in a branch, and then if we have is complete, we make an array and we just give in our objective ID as being the completed objective. And if this is not complete yet, we just return an empty array because clearly this has not been completed yet. We're almost done setting up the basic functions for this base object, which again, I get that you might not see how everything is going to fit together yet. There's a lot of setup in this first video. After we have all that done, we can start having a little bit of fun and actually like putting things together a little bit more. So let's make the next one, which will be set objective complete by ID. And this is going to take in a string array, which will be all the completed objectives. And we're simply going to check, hey, does this array that we're getting in, does that contain the same ID that this objective has? Because if the completed objectives contains the ID of this specific objective, obviously that means that somehow it's been completed. This is mostly relevant for the save and load system. When we get back into saving and loading certain quest data, I will probably go back over this anyway. But for now, if this contains the objective ID of this specific objective, what we'll just do is we will set this objective to be finished because we already have a function for that. And then we make one last function here, and this is get completion progress. And get completion progress also gets an output, which will be the completion rate, which will be a singular float value. Again, this is a little bit of setup for when we get into objective collections in the future, where we can get a value anywhere from 0 to 1, depending on all of the sub-objectives that have been completed. That is why you had that nice little progress bar in the beginning of the video for each quest and each individual sub-objective in those quests. For the most basic objective though, it's fairly easy to calculate that. We just check whether or not it is completed, and we just get a select float of that. And if this particular objective is completed, we'll return 1, and otherwise we return 0. It's very much a 0 or 1 kind of deal here. You could even just like directly plug in the bool to the float output pin, I think. This effectively does the same. I think this is a little bit more logical to look at. Tells you a little bit more of what is actually going on, so I prefer doing it this way. And that is the base objective object. So for a general overview of how this is going to work, it's going to take a little bit of time for all of this to set in and all of this to start clicking together in a way that actually like makes a functioning system. But now that we have this base objective, what we end up doing is, let's go into our test quest. We are overriding the base quests init objectives. And what we'll end up doing is we can now construct object from class. And here we can put in our base objective, which takes in the objective name. So that'll be test, and then the objective ID. This has to be unique, by the way, for each objective in your game. So generally speaking, what I recommend is naming these something like quest name, and then added onto it an individual ID name. So in this case, that would be test quests objective 1, something like that. And this doesn't need to show a progress bar. This will then make this objective object, and that is what we will be returning with init objectives. Of course, in the eventual actual full system, you would make a subclass of this like location objective or objective collection or something of the like. After we initialize the objectives, we get that as a return value. So what we'll actually end up doing here is going back into our base quest real quick. On the event graph on begin play is where we will run the init objectives function. and we don't need tick or overlap in this case, so we can just delete those. So whatever the implementation of the child classes that we're going to be making off of this is, the base quest will make sure that it gets run at begin play. And then the objectives, we're actually going to promote that to a variable. We can just call that objectives. We'll change this variable type at some point down the line to a objective collection, but for now, this is fine. We immediately activate that objective because, of course, it's going to be the main objective of the quest. And then we also bind to the finish objective. And we will make a custom event to go with that, which will in turn call a event dispatcher on this quest. So we'll make a new event dispatcher here, and we'll call that something like a completed quest. So that way we know if we want to give things like quest rewards, that kind of stuff, we can do all of that in here as well. So let's call this quests completed, and we just call that out. Now, there's a handful of things that you can do already to improve this a little bit for future proofing, and that is selecting the event dispatcher for on quest completed. We're actually going to give it an input here, and the input will be a base quest reference. We'll call that something like completed quest. And if we now refresh this node, it'll actually say that, and we just forward the reference to self. So anything listening out for quests to be completed will be able to tell which quest is completed when they get the message from this event dispatcher. And in much a similar way, you might also want to do something like that in your base objective. So your on objective updated or on objective finished. Maybe what we want to do is we also want to put an input here for the objective that was just updated or finished. So we can just base objective, and let's also do that on update. So objective. So whenever we call those out, like on, I think, finish objective, we call them out, right? We just provide in a reference to self, just in case somewhere down the line that ends up being relevant. I will warn you that if we go back into the base quest, that's going to maybe result in a compile error because of this event that we just created here on quest completed that is hooked up to the event dispatcher. If it does, you just want to make sure that the event that you made has a input parameter or an output parameter in this case that matches the thing that we just added to the event dispatcher for objective finish. So in this case, that would just be a base objective reference. Now, again, this all is a lot of information about a lot of setup without actually implementing this into practice yet. I'm sectioning this off as its own video so that it's easy to come back to as we go along with later parts to this series, to see how all this is set up in the first place when we have a little bit more context. There's so many moving parts to a system like this that a video like this is kind of a necessary evil, I'm afraid. The rest of this course has been structured in such a way that each individual video actually has some meaningful progress that will create something that we can actually see working and that we can actually play around with. So it says in the next video, where we're going to focus fully on making our first kind of specific objective, that being a location objective. In the last part of our quest series where we got started, we had a lot of setup where we created a quest component and then a base quest and then a quest objective, and we didn't even really do anything with the quest component yet because there was a lot of things going on setting up the base objective and the base quest, and it's just a lot of overwhelming information. Today, we're going to put some of that into actual practice. We're going to create a location objective to work with. And we'll also set up a basic implementation of actually assigning those quests so that we can see something going on. So the way we do that is actually relatively easy. We come over to our base objective, which has a bunch of functions on it. As you might remember, we have this activate objective and finish objective and all that kind of good stuff. If you right click on that, we can make a child blueprint of this class and we can call this something like location objective. And for any time any quest needs to go to a specific location, this is the kind of objective that we will be creating. So let's open that up. Now, we already have a handful of functions, and the most important one is going to be, in this case, activate objective. So let's override that one. That's going to automatically call the parent function of this objective activate, which is going to just set the bool on this for is active to being true. we still want to do that. So we want to keep this orange node around. We're just going to add some stuff of our own for this specific type of objective afterwards. And the way we do that is actually relatively simple for a location objective. We're going to add in a new variable here, and this will be our location trigger, and that will be of type trigger base. So if you just type in trigger, you can see trigger base object reference. We'll make this a exposed and exposed on spawn type of variable, so that when we create a location objective, we can give in a location trigger that should trigger this to be completed. On activate objective, we pull in that location trigger and we simply bind to actor begin overlap. Now, fair warning, this will trigger whenever any actor overlaps with this specific trigger. So what you might want to do is set up some custom collision channel that your specific player character works on and tell that specific trigger to ignore everything except for your player character's channel. We're going to do this in a slightly different way though. What we'll do is we'll pull off of this event and we will create event. We need to do this because we're not in the event graph, we're inside of a function. So the way this works is we'll make another function that we can bind to this. So we can either select a function, which we don't have any matching functions, so we can just create a matching function. And this will be something like on location reached, which will have the information for the overlapping actor and the other actor. So in our case, we're just going to cast this to the third person character, because this will just check, hey, is the thing that just overlapped with us a third person character? Because the only thing that's going to be a third person character in your game most likely will be your player character. And if so, we just finish objective, which again is a function that we made last time, which just sets our objective to complete and calls out an event dispatcher. Now, doing this cast can be a little bit annoying because if you in your project use a third person character and then you go into a different project and that doesn't work quite as well anymore, that might be a little bit annoying. So a different way of doing something similar might be something along the lines of creating a blueprint interface, and let's call this quest utils. I will just get the quest component because we're going to need to fill out some quest component stuff anyway in a moment. And then we'll just have a simple output for the quest components, which of course will be of type, you'll never guess it, quest component. So quest component, object reference. This is always going to be a empty reference unless whatever we call it on implements this interface and this function and gives it an actual value. So now what we can do in our objective location, instead of doing a cast here, what we can do is on the other actor, we can get the quest component, and then we can just check if this is valid. This is only ever going to be valid when it is someone to do with a quest component. And if you want to go like real in depth, you can even check on that quest component whether or not it has this specific quest and this objective is active, and all that we're going to skip over because that gets a little tedious fairly quickly. That's only really relevant if you have multiple players running around in your world at the same time. That could potentially be triggering this. So now we have a location objective. It is as easy and as quick as that. So let's go back into our quests and let's actually put our interface into that folder as well. If we go into our test quest, the thing that we set up before to show you how this works, just as a quick little overview again, in our base quest, we have the init objectives. That is a function that is designed to be overridden. In our individual quest, we'll overwrite that with creating objectives. So I created this base objective as an example, but what we'll do now is I will create a location objective instead. So we'll look for the location objective class, which will have all the same inputs, but also now has a location trigger. And we're going to populate that by just promoting it to a variable, and we'll call this location1 and make sure that this is exposed. Doesn't need to be exposed on spawn, only instance editable. But now what we'll do is it initiates the objectives and creates this objective that is looking out for this specific trigger. So now you can see that we can have 10 different triggers in a bunch of different places in the levels, all corresponding to different objectives that are mapped to different quests. This is why you want to have these quests all be their own individual blueprint classes, because now we can more individually script them out for very specific behavior. So let's just show you how that works. We can get our test quest and put it into the world. We can see our location 1 over here is a variable that we can fill out. So let's put in a trigger. We can just make a trigger box, and we'll say the trigger box, we'll put that. Let's just do it like in my example project, and we're going to put it on like that little circle thing over there. So we'll just put it over here, make it a little bit bigger so that it's easier to overlap with, something like this, right? And then we can very simply just pick an actor from our scene. And now this objective is going to complete within this quest whenever we overlap with that thing. So we can test that by just going into our location objective here. And whenever this happens on finish objective, we'll just do in the base objective, we'll do a print string real quick that says objective ID. Let's append something to that, completed. And that's what we will be printing. Just as a temporary debugging solution, because we don't have any UI for this stuff yet, obviously. How are we going to activate this quest? For that, we need to actually build out our quest component. I left that off last episode because there was a lot of information already being thrown at you, but today we're going to make our quest component. So let's start by setting up the variables that we're going to be using. Number 1 will be our active quests. And we're going to keep track of these in a slightly maybe strange way at first glance. We're going to have a string map. So we're going to map a string, which is going to be each quest's individual ID, like objectives have individual IDs, so will the quests. So each quest is going to have such an ID, and then we're going to map that to a specific quest in our world. So our base quest objects reference. And then we'll make another variable, and that will be our finished quests. The reason we do this is because this way it's going to be super easy to save and load these, because we can't very well save and load object references because those are places in memory, and those are going to be different between every single play session because they're literally a memory address and they just get assigned to whatever memory is open in your PC at the time. So those aren't variables that you can save, but strings we can save. So we can save all the quest IDs, and then we can find the quests, the objects in the world, as the game starts up again with those quest ID strings on them, and then activate them. So that's the reason that we're doing this in maybe a slightly strange way at first glance, because I'm thinking forward to being able to save and load these quest data as well. Now it's time to start making some functions, because making functions is what we do best. Let's make some functions to check whether or not a specific quest is already in progress or is already started or anything along those lines. So let's say query quest active, so whether or not this quest is currently something that we're working on. You can also call this quest started, whatever you prefer. And we want to be able to do this by object. We don't want to be working everywhere with only strings, because that gets a little bit bothersome. We want to just pass around objects easily like that. So we'll say our item or our quest to check or something like that, which will be of type base quest. And then the base quest itself, I don't believe we have given a ID variable yet. So let's go open up our base quest. And as you can see, we don't have an ID variable yet. So we'll give this a quest ID, which will be a string, much like the objectives themselves. You could reuse, technically speaking, the objective ID of the topmost objective in your hierarchy. I prefer having this as its own quest ID variable, which we're going to just make exposed as well, so we can edit this easily in the world editor. Make sure to compile that, and let's actually just save everything that we've been working on. Now that we have our quest to check in our quest components again, now we can get the quest ID from that. And we can just simply check if that quest ID is contained in our map. And if it is or is not, doesn't matter, we'll just return that as a value. So instead of calling this query quest active, maybe it is more accurate to call this something like is quest active. And we'll just kind of copy and paste this over into a different function. And instead of calling this quest active, we'll call this is quest finished. And the only difference is going to be, instead of checking our active quests, we check our finished quests. We just check if the quest ID is present in this map of finished quests. And we need these two because we don't want to be able to add a quest that we've already either started or a quest that we've already completed. So when we're going to make the start quest or the add quest function, which will be next, we want to be able to check both of these before doing anything else. So let's make that add quest function. The quest that we're going to be adding will be our input parameter. So this will be our quest to add. And before anything else, we're going to query our active quests and our finished quest. And a funny thing about that actually is you can go into both of these and you can mark them as being pure. Because when a function is called as pure, it's effectively called in reverse. It doesn't have an execution pin. It's just whenever we reach something with an execution pin that uses this, that is when this will get run. So pure functions are good for making sure you always have the most up-to-date data at the time of the data being requested. And it also doesn't use execution pins, so it doesn't make you hook up a billion different things. So the quest to add will go into both quest to check, and then we will check for both of these if they are not Boolean, and then that will go into a AND Boolean. So we want to check whether or not they are either not activated or finished. So a quest that we have not interacted with at all up until this point. So if they're both not active yet or not finished at all, that is when we will move on. So we'll put in a branching node, and if this is true, that'll be where we put in the rest of our code, where we will get our active quests, and we will add to that the quest that we are starting, which comes from our inputs here. And then we're going to be putting that in under the get ID, our quest ID, as the string key that we're putting into the map. So this way we can find the quest objective by putting in the quest ID. Now, going into our quest base class, wherever it might be, quest base here, we set this up as init objectives on begin play. That was good for troubleshooting purposes before. We didn't really end up using it, to be fair, so that might have been a little confusing. I'm sorry if it was, because we're going to make a custom event for this instead that we'll just call start quest, because we don't really need to initialize any objectives or bind to anything or do any like weird stuff until the quest itself has become active. We, of course, don't want to be able to complete something by accident before even starting it in the first place. So back in our quest component, now that we have that working, we can get our quest to add. And after we've added it, we can start the quest. Now, when we complete a quest, we want to move it from the active quests to the finished quests as well. So we get our quest to add again, and we bind to on quest completed is the event dispatcher that we made ourselves, and we'll create an event for that, create a matching function, and we'll call that function complete quest. And complete quest is actually going to be really easy, because we just get our quest ID and then we remove that quest ID from the active quests and we add it to the finished quests. So that is just as easy as saying remove and add. And we don't even need to supply in the object reference for remove, because you can just remove something by only providing in the key. And for the finished quests, we can provide in the ID and then also need to provide in the object. Technically speaking, you might be able to get away with just making this an array of only strings, but I like having them as a map. So now when the quest is marked as completed, it's automatically moved from the active quests to the finished quests as well. And with that, we have a functioning quest on our hands. The only thing that we need to do is add this component to our player character and add in a little bit of code that adds this quest to that quest component. So let's do both of those things real quick. Let's go into our third-person character, and here I will add a quest component. And then, of course, also don't forget to, in your blueprint, go into your class settings, go into your interfaces here, add an implementation for interface, and add our quest utils, which will get our interfaces opening up here. Get quest components, we just provide in the quest components. And I will just add in a quick trigger box, and we're just going to do this through the level blueprint in this case. Ideally, maybe you want to make an actor that can specifically like supply quests or whatever. But then again, maybe you want to do this through like a dialogue tree or a number of different ways how you can do this realistically speaking. So I'm just going to do this, for example, through the level blueprint. So we open the level blueprint and we get the on actor begin overlap. We check the other actor and we get the quest component, which is the interface that we set up last time. And if the quest component is valid, then we simply add a quest. And the quest that we will be adding will be this quest that physically exists within the world. So we just click on it and then we create a reference to it in our blueprint here, in our level blueprints, and that's how we can add that quest. So now, real quick, what will happen when we overlap with this thing? When we overlap with this thing, it's going to get our character's quest component. Anything that doesn't have a quest component is going to stop there because it's not going to be able to get a valid quest component as a return value. Only our player character will have a quest component to return. So it's going to supply that quest component, and then our level blueprint is going to activate this quest in that quest component. That will, if it is not yet activated or finished, add it to the active quests list, and then also start the quest. Starting the quest will initialize its objectives, which is going to, in this case, look out for this to be overlapped with. And now we'll be able to see if we go over here, it'll print out a hello. I just put a print string in there real quick to show you when the quest is activated. So now we have that quest activated. We don't have any visuals yet to prove that or to see what quests are active or not. Something that we'll do in the future. But now it's looking out for the trigger volume that we placed over there. So when we go over there, we will get a print string showing us that, in fact, that objective has been completed. So test quest objective 1 completed. And just to show you, if I don't pick up the quest first, it's not gonna do that because we don't have that objective existing yet, so that we don't have anything listening out for this thing to be overlapped with, and as such, we can't complete the objective yet. Only when we actually pick up this quest by overlapping with the trigger box over here, will we be able to do anything with the trigger box over here. Now, this doesn't technically complete the quest yet, because the quest itself is only going to get completed once all the objectives that are assigned to it will be completed. And we can build some simple implementation for just this one-off kind of objective, but that's going to be a little bit wasteful because I intend for the very next video to dive into setting up nested objectives or objective collections, meaning that we can have multiple objectives that all need to be completed to finish up a quest, which is going to allow you to nest as many collections as you want into a singular quest. That objective collection is going to have all of the logic tied to it for completing the quest as a whole, because for 99% of the quests that you're probably gonna do, you want to be able to set up more than just one objective. But we'll talk a little bit about that next time, because for now we have a functioning start to a quest system. So hopefully it has all been clear to you guys so far. And next time, we're going to get into some really, really exciting stuff. Now that we have basic objectives working for our quest system, let's dive into something a little bit more complicated and a little bit more expandable, most importantly, and that is being able to nest objectives. What does that mean? We're going to go from just simply one objective, as we have right now. We can pick up a quest over here, and that quest just has the objective, go to this other trigger box, it triggers, and that's kind of all there is to it. We're gonna make something that will allow us to go to maybe go through 3 trigger boxes, or 5, or 16, either sequentially or in any random given order. And for something like that, we will need to set up a objective that can hold multiple other objectives. And this is kind of where all of the things that we have set up so far are going to really come together to form the backbone of this system. So let's go to our base objective class and create a child blueprint of it. And we'll call this a objective collection because it's going to be a collection of objectives. It's very descriptive in its naming. Now, there's going to be a lot that we have to go through here today. So if at the end of this video, you're feeling a little bit lost and you feel like needing to watch things through again, that will make sense. As a matter of fact, after watching this video, maybe going back to the first part of this series in its entirety and going through that again with a little bit more context of how things are going to like click into place will give you a better understanding of the system as a whole. But for now, let's just get started on implementing all of the objective collection stuff. So the most important part of which is going to be some variables. So we set up our sub objectives, which will of course be a variable of type base objective. Here we go, base objective, and it's going to be an array. And the wonderful thing about this is because objective collection itself is a child of base objective, this sub-objective array can itself hold multiple different objective collections, which then, all of which could in theory hold objective collections. So you can stack this infinitely as much as you want or need to. Now, there's going to be a handful of things that we need to implement and override. The first and most important of which is activate objective. We can implement that as a function. If you prefer, because it doesn't have a return value, you can actually go into the event graph and activate objective here. And you can call it as an event or like implement it as an event instead. This way you can more easily like bind to event dispatches and that kind of stuff. If you do that though, important is to right click on this thing and add call to parent function, because the parent function is the thing that's actually going to like flip the ball here to being set to active. So when we activate this objective collection, what we want to do is we want to first and foremost get our sub-objectives that we have here, and we want to for each loop over them, because every one of these sub-objectives is going to need to be watched. And what I mean by that is every one of these we need to bind to updates objective. And we will bind to that with a custom event here, and we'll call that a forward update objective. Because all that this is going to do is when any of the sub-objectives get updated, it also needs to update this objective. This is mostly to get things like progress bars working properly in the future. If you're not working with progress bars, this is not entirely super important, but you might as well set this up. So when any of its objectives get updated, we call on update objective here as well. And the thing that we're updating will be just self, just in case that ever becomes relevant. So now we are bound to all that. And because we're forwarding all this, again, this will work a couple of nested layer deeps. Because let's just think about how that works real quick, right? If we have a quest here that has a objective collection, that has an objective collection, that has an objective collection, that has an objective collection, that has a handful of objectives. When this objective over here, let's make this green, when this objective over here updates, it's going to send a signal to its collection to update, which is going to send a signal to its collection to update, which is going to send a signal to its collection to update, which is going to send a signal to like the topmost collection in this case to update. So this can go as deep as you would like. Now, after we do that, we get into the complicated bits. So we're going to make a variable here, and this variable will be whether or not we need to do these objectives in order. So this is going to be a simple bool, just a singular value, and both of these actually need to be instance editable and exposed on spawn, because that's how we're going to be setting these. So for each objective collection, we can either choose to allow these to have to be done sequentially, so in the order that they appear in the array, or in any given order at all. And we need to implement logic for both of those. So if we take the ordered variable here and we put in a branch, we're going to need to create two different paths for this. Honestly, the easiest of which is if we don't do anything ordered, because if we don't do anything ordered, we just activate all of the objectives inside of this, and that's that. So let's do that first. We get our sub-objectives again, and we simply do a for each loop over all those. And with those, we very easily just activate objective. That will activate all of the sub-objectives, which if one of those is its own objective collection, that objective collection then has its own ordered variable as well. So you very much can make something like this, right? Where we have like 3 objective collections as our objective collection for like the quest as a whole, and say, well, this one needs to be done in order. So we need to do number 1 first, then number 2 unlocks, then number 3 unlocks. But for this collection over here, when we unlock it, we just like unlock all 3 at the same time, or all 5 at the same time, or whatever. And just as before, this is infinitely nestable as much as you need it to be. So for each individual collection, you can say whether or not they are ordered or sequential. Anyway, after we activate the objective, we're going to bind to finish objective as well, because we want to keep track of when they are finished, of course. Because when any of these objectives finish, of course, that's also going to mean that we update this objective collection, because suddenly one of the things inside here has finished, which then will mean that our completion percentage of this objective collection, the quest as a whole, is going to need to be updated. So let's make that a custom event, and we'll just call this object finished or something like that. And here we, for the first time, actually use the objective that is getting provided in, because as you remember, anytime we call onUpdate or onFinished, we're providing in the actual objective, but we haven't been using that up until now. Here we actually start using that, because once it is finished, we actually want to unbind from this as well. So we unbind from finish objective, this very thing. So we're first binding to it when they first get activated, but then when they are finished, we just want a real quick unbind so that it doesn't fire again in any like weird scenarios. And then anytime any of these sub-objectives are finished, we want to check whether or not this objective as a whole is finished, for which we're going to need to make a quick function. So let's make a function, something like check objective finished. Let's call it check objective collection finished, just to be sure that everything is very descriptive. And we'll just get our objective collection, which we're going to for each loop over. And here we're going to do a neat little trick, is for each one of these, we're going to check whether or not it has been marked as completed, because we have a value for it being completed or not. And if at any point this returns false, we're going to return the function, which means that we prematurely end it. Meaning that if we make it all the way through the for each loop, we didn't get any sub-objectives that were marked as complete being false, which in turn means every sub-objective has been completed. So then we can run the finish objective function that we made before, which again just does in the base implementation, set the thing to completed, call itself out as a completed, and in this case prints a string just for debugging purposes. But it'll only be allowed to call this finish objective if all of these sub-objectives are finished. So whenever we run this function, it's going to check through all of its sub-objectives, and we run that every time any of these sub-objectives get finished. So we bind on objective finished for each one of the sub-objectives, and in there we check objective collection finished. Now, no matter what happens, after we complete this for each loop, and after any of these objectives get updated, what we for sure want to do is we want to call update it. So call objective update, and the objective that we're going to update, of course, will, as always, be a reference to self. And that will be called after we complete the for each loop, but also at the end of this onObjective finished event that is bound to every sub-objective. And here you can see we start doing some double bindings. We're binding effectively the same thing to whenever something is being updated and whenever something is being finished. In this case, we want to update this objective collection in either case, but sometimes you might only want to send a message through when something is being updated but has not yet been finished, or something specifically has been finished. Like in this case, we want to check whether or not the objective collection as a whole is finished. That's only going to be relevant if any of the sub-objectives are finished. If any of the sub-objectives just get updated, but haven't been finished off, there's no need to go through and check whether or not this objective collection is now finished. So that is the code for unordered quests. So this is just going to unlock every single one of your sub-objectives in this collection at once. Now, the slightly more tricky version is going to be things that have to be done in order. It's only going to, by default, unlock the first entry in your array, and only once that objective has been completed will it start adding in the next objective on the list. So for this, we'll make a new function as well, and we'll call this activate next objective. And we're going to do a pretty similar trick here with the for each loop as before, but we're going to do it slightly differently. So let's get our sub-objectives, and of course we're going to for each loop over those, and for all of these we're going to check, hey, which one is not yet set to being active? So we're going to check get is active, and the first one it finds that is not yet active, we're going to activate, and then we're going to break out of this for each loop by doing an early return. So we get our array elements and we activate that objective only if it is not yet been activated. And then we also, from that, bind to finished for that specific objective. And this is going to be a input parameter for this function. So that's something that you probably don't see a lot of, generally speaking. passing through these event dispatcher, these delegates as like parameters into functions, but it's a thing that you like fully can do and it will work. So we can bind to this, and then in the event graph, we can actually implement an event that this is going to bind to. And then, of course, we add in a return node to end the function so that it doesn't endlessly keep going and activate everything. That said, though, if we are running this and we've made it through all the way and everything is already active, assuming that we built the rest of our code in a sensible way, this function will only ever be called in response to the previous objective being completed. Meaning that if we make it all the way through this for each loop, we also have finished off the objective collection as a whole. So then we can finish objective. Now, if you start putting this activate next objective in places aside from what we're showing in this tutorial series, that's entirely up to you, but do be aware that there is this check built in with the for each loop for if we make it to the end of it, we're going to finish this objective collection as a whole. In which case, what you might want to do is you might want to check objective collection finished. This is a little bit wasteful because after the end of doing a full for each loop, we're going to then do another full for each loop again. This is a little bit more safe to do because it's never going to accidentally finish off your quest by just unlocking an objective if you're using this function improperly at any point. Just using the finish objective here makes it slightly more CPU friendly. We're going to do this because it is a little bit more safe. Time to go back to our event graph, however. And there we're going to, if ordered is true, we're going to, and in here, if ordered is true, we're going to activate next objective right away. And this is just going to go through and check every single index in your array. And seeing as how nothing has been activated yet, it's going to just immediately activate index number 0, which is the very first objective of this list. With this event input, we're going to add in a custom event, and we'll call this something like objective completed, which is different from onObjective finished, apparently. Maybe name these a little bit better. This is onObjective sequential completed or something like that. We're going to do something very similar. We will unbind the finished objective, and that's going to unbind from the very event that is calling it, so that we don't accidentally like call it 2 or 3 different times. And then immediately we're going to activate the next objective. So whenever this fires, when an objective is completed, it's going to try to activate the next objective, which is also, of course, going to go back and bind to the same thing here. And for both of these also, we can hook that up to the call on update objective, because in both cases, a new objective or sub-objective has been activated. That is, to put it mildly, quite a lot of things happening there. But this is the backbone of our system now. This is the most important central bit that everything else is going to be functioning off of. So let's just take a step back before we implement any other weird stuff, because believe me, there is multiple different things that we can still do in this objective collection to improve it. Let's just go through and see how we would implement an objective collection. So in order to do that, we're going to go back into our base quest, and where we before just had our objective variable here from initialize objectives as a normal base objective, we're going to change that to an objective collection instead. Because effectively any quest that we want to make, we want to start off with the first objective being a collection, so that we can make multiple like collections of that if we want to. Which also means that initialize objectives itself is going to need to be updated to return a objective collection as well, because otherwise these won't connect up properly. And everything else here can still stay the same, because in the end, activate objective is just a function that we are overriding and adding some more stuff to with the collection. But it is a function that still exists on both the base and the collection. So if we go back into our test quest over here, we have our construct location event, where that's no longer quite what we want it to be. What we're going to want to do is we want to construct another object here. And the object that we're going to be constructing will be a collection instead. So an objective collection. And this will, if we just refresh the node real quick, still have an objective name. This will be your first quests. It will have an objective ID. So this will be collection 1, for instance. Show a progress bar. We're going to just ignore that for now. This is going to be an unordered quest, so we can do it in any way, shape or form that we want, or an unordered collection, I should say. But the sub-objectives that we make are going to be important here. So the way we set that up is we just pull off of this sub-objectives array input and we make an array. Now let's make an array with 3 different objectives to complete. So we effectively just get this location objective, because that's the only type of objective that we have as of right now. And we duplicate that over 2 more times to create different objectives. And here you can start seeing the location objective is just a template, right? It's just a type of objective that we can create. We can now link this location objective to 3 different trigger boxes, which we'll do. So location 1, location 2, and location 3. And each one of these objectives can be linked to a different one of these trigger boxes. Of course, it is important to make sure that the quest IDs are not the same. So let's call this test quest objective 2 and test quest objective 3. And we'll call this walk on circle. For now, that doesn't really matter because we can't see it yet, but that's going to be relevant at some point. This will be walk on the ramp. And this will be, I think I called it walk upstairs in the example projects or something like that. So we'll just call it the same thing. And now we can plug all of these outputs from these construction nodes into this make array in the order that we want these to complete it in, if this is an ordered quest. So 0 is going to be the first thing that it does, 1 is going to be the second, and so on and so forth. This is also going to be the order that they show up in either way, even if you don't check ordered quests. And then the return value from the objective collection is going to be the return value that we put into this node. But you can see how this is very expandable, right? Because we can very much, instead of just making these 3 simple location objectives, anything that we want to put into this array can itself be an objective collection with its own separate objectives under it. Each one of which could be an objective collection. I've gone over this point a million times. I'm sure by now you get it. So if we compile this and we go back into the world, we can now see that we have a handful of new objectives that we can assign. So let's create a trigger box here and a trigger box like right there. And then I think the first one was the circle, the second one was the ramp, and then the third one was walking up here, I believe. And quest ID, we'll just give this an idea. Your first quest. Something unimportant, really. And here we can go in, collect the quest. It has a hello print string, which is hard to see, but now we can do these in any order we want. Objective 2, objective 1, and then objective 3 over here. So that's how that works. But now, and this is the wonderful thing, if we go back into our test quest and we say, now actually this collection that I'm making here, which is the entire collection of objectives in this case, I want those to be ordered. And now it's only going to allow us to do these in the order that we provide them into this make array. So the circle first, the ramp second, and the staircase last. So if we go and try to do the ramp first, you will note that it doesn't actually complete the ramp because it's not actually looking out for the ramp yet. That objective hasn't been activated yet because now they're getting activated one at a time in order. So this one, however, will work. And now that I've completed objective 1, it is looking out for objective 2 and going onto the ramp will complete it because now that is active. Now that I've completed objective 2, going up here, we'll complete objective 3. And now that we have all that in place, we can actually look out for our master objective collection, which is the objective collection that eventually gets returned in this node. So let's go into our base quest. The thing that on start quest, we init objectives, then we set that to a variable. The reason, by the way, that we set it to a variable is to do with garbage collection. You need to have a reference to objects to keep them from being garbage collected. So as long as we have variables referring to them, Unreal is going to leave them alone and not destroy the objects because we're still working with them. But you can see that when we finish this objective, it will complete the quest and call on quest completed. Which if you want to, you could make a variable here for quest completed or whatever. That might become relevant a little bit later on. We'll see if we actually end up doing that or not. But on our quest component here, we can then check in our add quest. We have on quest completed that runs complete quests, which removes it from active quests and puts it into finished quests. So if we go into our event graph real quick and we go into event tick, what I want to do just to show you is I'm going to for each loop over both of these. So we get the keys out of the active quest. And then I for each loop over those. And then I want to find every single quest from this. And then I'm just going to print the name or the ID of those individual quests. And I will actually do that for the duration of delta seconds so that it doesn't spam everything entirely full. And I'm going to do the same thing with the finished quests. So after completion, I do a for each loop over the finished quests. And we'll do the active quests in green and the finished quests we'll do in red so that we can still like differentiate them fairly easily. So this one we'll do in a more red color. Also duration is delta seconds. So now my component will be printing out all of its active quests and all of its finished quests every frame. So you can see I don't have any active quests, but now that I overlap with this, I have my first quest here, which I need to complete obviously in order as we discussed. So let's complete that. And you can see this is going to get moved to the finished quests because now it is printing in red. So I have officially finished this quest, meaning that we have a functional quest system. We have no way to show any of that yet, which is going to be a huge part of what we do moving forward, and then we add in like other fun features. But the basis and the central mechanics of our quest system are now in place. We have our fully functional quest system, more or less, but now we still need something to show off how far along in the quest we are. We want to show all of the objectives that are available to right now in one of these little tree views, where we can expand any collection of sub-objectives fairly easily. And while Unreal has a built-in tree viewer option, we're actually going to build this from scratch, because I think it is worthwhile to build something specifically for what we need it to do, so that you properly understand how everything works as well. So we're going to need a handful of different widgets that we're going to stack into each other to make this work. We're going to just make a normal widget blueprint here, which will just be a user widget, and that will be our quest tracker or something like that. This is just going to be a general overlay that we put onto the screen for testing purposes. Of course, eventually, if you make this into a full game, this is likely going to be actually somewhere within like a pause menu or whatever. For now, the way that I like to do this is just adding a canvas panel as the base here, and then we're going to be adding 2 borders into that. The first one of which will be in the top left-ish, something like this. And I'm gonna change the brush color to being slightly more gray and then about 20% opacity. Inside of that border, I put a vertical box in which we can put a simple text. I will align that to the center, and this will just say active quests or something along those lines. So now we have a little menu that says active quests. Then next up, we're going to add in a scroll box. And this is going to be a little bit funny the way we set this up. That's also going to be in this vertical box, by the way, under the active quests. And this one we will set to being a vertical scroll box. And then inside of that scroll box, we're going to put another scroll box. And this one is going to be a horizontal scroll box. This creates effectively a scroll box that will be able to scroll in both directions. This is mostly relevant for if you have a long list of quests, and then also quests that go a lot like in depth with a lot of layers, because every single layer with sub-objectives in it is going to be offset ever so slightly to the right. So if you get a lot of nests in, eventually you're going to go off the right side of this border, in which case we want to be able to scroll. Of course, if you're making a menu where that's not an issue, you don't really need to do this. And within there, we're going to put in one more vertical box. And that's the basic layout for how this is going to work. So you could make this into its own sub blueprint as well, if you really wanted to. Because what we're going to be doing is we'll copy this entire setup over to the right side of the screen as well. Again, this is mostly for troubleshooting purposes. We put the anchor in the top right and we change the text to finished quests. So when we get a quest, it's going to be added to here. And then when we finish it, it's going to be added to there instead. Now, how do we actually display the quests themselves? Well, for that, we're going to need a handful of other widgets. So let's take a look into making those. The most important of which is going to be a user widget as well. That will be our objective viewer. this is effectively going to be the custom tree viewer that we're going to be making. I will just open that up real quick, but we're not going to do too much with it quite yet. We will very simply just add in a vertical box, and that's going to be all we have for this right now. Because in order to do anything with this, we're going to need to make our quest text, the thing that actually shows the name of every single objective in our quest. So we do that by making a user interface, and this will be quest text, just as easily as that. And this is the first one that we're actually going to build out, because once this is built out, we can then go back into our objective viewer and implement everything about every single quest text that we'll create very, very easily and very simply. So the quest text itself also is going to start with a vertical box, because we're going to be stacking a couple of things on top of each other. I will set this one to desired on screen just to have a better preview of how big everything is. Then we'll start by adding in an overlay, because we're going to have a couple of things parented to the same thing here. The most important of which being a button. So let's put a button into the overlay here, and that's going to make the entire overlay clickable. Let's go into the button though and go to the background color, and we'll set the alpha for this to 0 so that the button actually is invisible but still interactable. We just can't see it. Of course, if you want the button to be visible because all your quest text needs to have a certain look to it, feel free to do that. I like just having the plain text a little bit more. Then under the button, we'll add in a text block. So now the button is effectively just the text. Anywhere we click on the text will be fine. Important to note though is that the button does need to be set to fill horizontally and vertically, so that it's actually as big as the text. And then we can add a progress bar, not into the overlay itself, just into the vertical box, so that it is added in under the text. And this is the layout for how every single individual objective is going to be implemented. So let's go into the event graph and actually set some things up here. The most important of which is going to be the button. We want to add the onClicked event for that button. And we want to add an event dispatcher to this, and we'll call that something like toggle collapse, something along those lines. And when we click that button, we're going to just call on toggle collapse, and we'll implement the actual logic for that in another place. But now we have a way to toggle it between collapsing and being uncollapsed. Now, event construct. We don't need event tick necessarily, and not even pre-construct. We only need event construct at the moment. We want to go back into the designer and make sure that our text is set to being is variable. And while we're at it, we might as well do the same thing with the progress bar. Just check whether or not it is set to variable or not. And then we can pull in our text block and we can set the text, which you can either do directly with the variable or with set text as a function. And we're just going to promote that to a variable. We can just call that in-text. That is actually a perfect name for it. We'll mark that as instance editable, but also expose it on spawn. And now we're going to do, but how do we now get the text for this? Well, the way that we're going to do this is we're going to add in another variable, and that will be our objective that we're going to be displaying every information about on this thing. So that will be a base objective, which still will be able to take in things like a objective collection, but we'll only be able to access things that are on the base collection, which we will make instance editable and expose on spawn. So whenever we create one of these text quests, we need to give in the objective that is going to display. And with that, we can get the objective name, and that is going to be our text. Then we can also get whether or not it is completed. We don't really need to worry about it being active or not, because we'll do a little bit more about that in a moment. But the reason that I want to mark this as completed or not is because I'm going to kind of change around the text, specifically the text color. I want the text color to be a little bit more of a dull gray, showing you that you've completed a specific task. So let's get this text block, and if completed is true, we want to set the color and opacity. So set color and opacity. And let's just make a slate color, and here we can just create whatever color we want. So what I'm going to do is I'm going to set the saturation to nothing, and then we're going to set the color to being a little bit more of a darker gray, meaning that if this is true, we set our color to this dark gray instead of the pure white. And then also, once this thing has been completed, I don't think we necessarily need the progress bar for it anymore. So we can set the visibility for the progress bar to change to hidden. Then let's go back. That is if our task is completed, but if our task is not yet completed, we need to set some other stuff up. So we need to figure out whether or not this task is supposed to show a progress bar to begin with, because some tasks we might not care about showing a progress bar for. So we made a bool for that, a show progress bar. So let's get that. And we can do another branching node there. And there is actually fairly easy. If show progress bar is false, we just hook up to this, set visibility to hidden. If it is true, however, we want to set the progress of the progress bar to match the completion rate of this specific objective. So let's get our completion progress, which is a function that we made on the objectives. That gets us a float value, which is going to be between 0 and 1. So we can just use that for our progress bar to set the percentage, which is a 0 to 1 value. And that effectively finishes off the quest text that we had to create there. So now it's just a matter of instantiating a bunch of these for every single quest and every single objective that we currently have active. And that is where we finally get back into our objective viewer. This thing is going to be rendering everything to actually show those quest texts. And there's going to be a little bit of a mess as far as nodes go here. So stick with me. Let's go into the event graph, and on event construct, we're going to do quite a lot of stuff. So this objective viewer is going to take in individual quests. So we're going to instantiate one objective viewer for every single quest that we make, meaning that it's going to be taking in a collection of objectives. Then the quest tracker itself is going to be responsible for providing multiple different quests in, if that makes any sense. So the very first thing that we want to do here is make a new variable for the objective that we're going to be creating this thing for. This can be either just a normal objective or an objective collection. So the type will just be base objective, but we're going to be checking whether or not it is an objective collection. So we'll mark that as instance editable and set to expose and spawn, because we'll populate that in a moment. But then we'll pull this in. And the first thing that we do before anything else is we cast to objective collection. So this way we will know whether or not we're working with a singular objective, any children of the single objective, or specifically an objective collection. Because if it's an objective collection, we need to then spawn in multiple other objectives as a child of this. But if it is a single objective, we know that we've kind of reached the end of a tree. Do be careful with everything that we're about to implement though, because we're going to be spawning objective viewers within this objective viewer, which can, if you make mistakes, lead to an infinite loop. And Unreal doesn't like potential infinite loops. So I was going to complain at you about that if you make any mistakes. The very first thing that we do is we're going to skip over these two pins here. These are going to both have some stuff going on for them in a moment, but that's a little bit complicated. So we'll save that for a little bit later on. We're going to check a bool here. So we're going to get the objective again, and we're going to check is active. So we'll just get is active, because if somehow we're trying to render an objective that is not currently active, we don't need to show that. Of course, if you want to, you can still add them in with maybe a different color or like a different material applied onto them. For now, things that aren't active, we're not going to add to this tree view at all. So only if is active is true on the objective that we're trying to render here will we actually move on. And what we will do is we will create a widget. And the widget that we're going to be creating will be a simple quest text, which takes in an objective, which is going to be the objective that we're working with right here. Then the output of that we can add in to our vertical box. So if we go back into the designer, we make sure that our vertical box is marked as a variable. We now have it accessible in our blueprint. We can add a child, and the content that we're going to be adding will be the return value of this create quest widget text. So that will be getting added to the vertical box now. And what we're actually going to do here is we're going to take our cast and we're going to move it a little bit later into the event graph. So we will start off with checking whether or not it is active and then doing all this. And after all that, we'll do the cast, because here we need to decide whether or not we want to spawn in another one of these objective viewers. We don't need to decide that until this point. Until this point, everything just works the same. It's just after that will the paths diverge on what to do. Because if this cast is successful and we're working with an objective collection, we then want to get the text widget thing that we just made, and there we want to bind to our on-toggle collapse. Of course, if this is just a singular thing, we don't want to be able to toggle the collapsed state of it because you don't collapse a singular objective, only multiple objectives. So that's why we do this casting here real quick. And there we will just make a custom event for it, and we'll call that toggle collapse state or something like that. And now we might need to go back into our objective collection real quick to add a variable that I haven't added before. So let's do that. Go into the objective collection, and we have another thing here. This will be a bool, and we'll just call this collapsed or something of the sort. So the object itself is going to keep track on whether or not it should render as being collapsed. As a general rule of thumb, UI elements shouldn't really decide a lot of stuff. They should only be reactive to the actual object's information. That way you're going to build your most scalable and most easy to work with systems. Let's make sure that we have that compiled and go back into our objective viewer real quick. Because now with that, we can get the collapsed variable and we can then set it again. So set collapsed variable, and we're going to set it to being the opposite of what it currently is. So the easiest way to do that is to get a not boolean of the current value. That's just gonna, if this is true, it's going to turn it into false. And if it's false, it's going to turn it into true, which means that we can easily flip the value of it like this. The reason also that we want to store that on the object and not on the UI element itself is if the UI element gets removed or it gets refreshed, it's going to go back to its default value. The object itself will be able to keep track of things. So that way, if you have a submenu that is opened up, but you collapse its parent and then you uncollapse the parent, the submenu itself will still be entirely opened up. And then we're going to add an event dispatcher here, and we'll just call that objective view updated or something like that. And we will call that out because if we toggle the collapse state of something, our objective view will have been updated and we need to re-render some stuff. Now, after that binding, we want to add in a branching node, and we're going to check if currently we are collapsed or not. Because if this thing is collapsed, we don't need to add in any other subviews because it's collapsed. So that kind of takes care of that. But if we aren't collapsed, that means that we're supposed to show all of the sub-objectives of this objective. So what we need to do at that point is we need to, from our objective collection, get all these sub-objectives. So get sub-objectives, and we're going to for each loop over all those. Again, hook that up to the full spin of our branching node. And for each one of those, we're going to create a new widget. And the widget that we're going to be creating will be the objective view. So objective viewer. Again, this can be a little bit tricky because we're creating more objective viewers within this objective viewer, all of which can potentially create their own set of new objective viewers infinitely on and on and on. So do be careful with doing this, but it's just going to take in the objective for each one of these sub-objectives, and then we need to add that to our vertical box. So we add those to the vertical box. We just add child for each and then each individual one of these. And after that, the thing that we get back out of adding a child is a panel slot object reference. That is the actual information on how this will slot in to our vertical box. So in our case, we know that this is going to be a vertical box slot. So we can cast to vertical box slot, and that will give us the opportunity to set the padding information for it. And this is going to be the way that we set the offset for each layer of nesting. So we can split that structure pin. And what we'll just do for now is we set the left padding to 20. So each layer of our system will be offset by 20 pixels to the right. So we can have like a objective that has a couple of sub-objectives. And if any one of those sub-objectives has its own sub-objectives, it's going to offset those. And if any one of those has its own sub-objectives, it's going to offset those, and so on and so forth. So it's going to create like this diagonal system. And then the very last thing that we need to do is for every one of these objective viewers, we have a objective view updated. and we're just going to bind to that. So objective bind to objective view updated, and the only thing that we need to do there is a custom event. We'll call that forward update because it's just going to forward the update into the next layer. Again, much like we did with the actual objective collection itself, if we go back to this example of having a couple of layers worth of objectives, right? So we have this layer, which is a sub-objective of this layer, which is a sub-objective of this layer. When this one here gets updated, it's going to send its message forward to this, which is going to send its message forward to this. And again, this can infinitely stack on top of each other. And that, for the most part, is the functionality for the tree view that we have just created. So as a quick overview, we check whether or not something is active to begin with. If so, we add a quest text with the name and everything that the quest text itself fills in here. We'll get back to this in a moment to make this a little bit more neat and a little bit more complicated. Then we'll add it to the vertical box. Then we check whether or not the objective that we just added is an objective collection. Because if it's not, we're just done. There's nothing else that we need to do. But if it is, we want to make sure that we can click on it. So we bind to the toggle state collapse, which will toggle the collapse state for it, let our system know that something was just updated. We want to check whether or not this collection currently is collapsed or not, because if it is not collapsed, that means it is opened up. And we want to add more objective viewers as children to this that correspond with, again, each one of those is going to run here from the beginning. Going to just add them if they are a singular objective. Going to check if the objective that we just added is a sub-objective or has sub-objectives. And then when it gets to this, it's going to loop around until it finally gets to the final layer, which is going to be just singular objectives. So with that, let's go into our quest tracker and make sure our quests for active and finished are added to this, which is remarkably simple now that we have everything else set up. Let's make a separate event for this real quick, shall we? Because we can just make a custom event, update quest lists. This could be two separate events, but I'm going to do it with just one. For the ease of reading everything, I'm going to break them up into a sequence node, because updating the active quests and the finished quests effectively is the same code with just a variable swapped out, which is why you maybe want to look into making that its own little sub widget, of course. But the first thing that we're going to do is I'm going to get the scroll box from this one, and I'm going to make sure actually that it's a variable, and then we clear all the children out of it, because we're going to, every time we update the quest list, we're going to redraw everything from scratch, because that's just the easiest way to make sure that everything is up to date. So we first want to get rid of all the old information. Then we need a reference to a quest component. So let's make our quest component. We'll set that to be a quest component object reference, which I'll just set to instance editable and expose on spawn. You can just get this from player character and get quest component with the interface that we made. I like doing this a little bit better because it's slightly better form. And with that quest component, we can then get the active quests, from which, of course, we can get the keys, which we can use to run a for each loop. Now, this is a little bit funky because you can for each loop over a map in this way. If you get the keys and you do a for each loop over the keys, you can then use the map's find function to find that key in the map and then get the actual, like, in this case, object out of it. And for each one of the quests that we can find, we're going to be adding a new widget. So we create a widget, and that widget itself is going to be a objective viewer, which of course needs an objective, but we can provide that in because we have our quest here. So we can get the objectives, because it's a variable that we have on our base quest, and that we can provide into this. So again, this is going to run all of that like recursive code that we made here on the first set of objectives. And then if there's any objective collections within those objective collections, within those objective collections, within those objective collections, it all takes care of itself. We, of course, then take this scroll box and we add that objective that we just created as a child. So we hook that up into the contents. And then the update quest list event that we made here, we will actually bind to that update event dispatcher that we made. So we can bind to onViewUpdated. And whenever the view is updated, we're going to just run this update quest list. So any of the things that we are instantiating and creating and adding as like children to all these boxes, they all have their little signal like, hey, I just updated, I just changed. That's going to send its signal all the way back up to this quest tracker widget, which will rerun the update quest list, which will first clear everything out and then just new up-to-date versions of everything. That's on a very large scale, not necessarily the most performant way to do this, but it is very much the easiest way to do things. If you want to be a little bit more performant, what you do is you only reconstruct the thing that actually changed. Because right now we're also reconstructing a bunch of things that didn't actually change. So that might be something worth looking into at a later date. And then we can pretty much copy all of this over and we'll just change a couple of things around. So we make the other scroll box over here also a variable. And then we can just plug that into everything that has a scroll box in the bottom here. So that's these two things. And then instead of getting the active quests, what we'll do is we'll get the finished quests and get the keys from that and use the finding on that. And that effectively, I think, changes everything around properly. So we can also hook this up to the unupdated quest list. Also, probably a good thing to make this into two separate events so that it doesn't redraw both every time something changes in either. There is a little bit of CPU optimization to be done with this for sure. But with that, I think we are effectively finished up with all the UI stuff, which it takes a while to set up, but then we should never have to look back at it ever again. So let's go into our third-person character and wherever it might open, there we go. And on begin play, I'm going to just real quick add in a create widget. And that widget that we're going to create will be our quests tracker that takes in a quest component, of course. That's going to be the quest component on this character itself. You can also add this directly to the component if you prefer. Kind of depends on how you're implementing this and if you're doing like multiplayer and stuff. A lot of things that I'm doing here aren't necessarily ideal for multiplayer related stuff, but this is the easiest way to do it. Otherwise, what we can do just to keep things a little bit more scalable is go back into here and in event begin play in our components, do all that instead. And if you do that, the quest component reference can just be self because we're now inside of a quest component. Either way, what you want to do is after creating the quest tracker is real quick update the quest list. This is going to not really do anything at the moment. We'll add this. We'll also get rid of these print strings actually. At the moment, this is not going to do anything, but later on, we'll add a saving and loading system. So we want to update the quest list immediately after we load some stuff as well. So that's why I'm already adding this in here, just as a little bit of future proofing. Another reason that it might be nice to do this within the component is because we're going to need to hook up a couple of things to functions that we made previously inside of this component. So after we create this thing, it'll be good for us to promote this to a variable. We'll call this something like quest UI, so that we can access it easily in all of these different functions. Because when we add a quest, obviously, we're going to want to run that update quest list. So first and foremost, let's go to add quest. We already have a couple of nodes ready and waiting for us. And he will need to bind to whenever this quest gets updated so that we know to redraw some stuff. Again, this is part of the reason that I'm just redrawing everything so that we can share one function across a lot of different uses. So for this, we will need to go to our base quest and we need to add in another event dispatcher because at the moment we only have quest completed, but of course we also need quest updated whenever any part of the quest itself, any of the objectives send over an update, but the quest isn't quite completed yet. We want to run quest updates. So on start quest, we bind to update objective as well. And this update objective is just going to make a custom event here real quick, update quest. And that's just going to call out quest updated so that whenever any of our sub-objectives are updated, it'll also update the quest as a whole. And now that we have that, we can go back into our quest component on the add quest function. The quest that we added, we also want to bind to quest updated. I like to do it before starting the quest because if we do it beforehand, it'll also immediately implement the update for the initial start of the quest itself, meaning that it's going to immediately show everything on screen the moment the quest starts. So from this, let's create an event, and we create a matching function, which we'll call something like update UI. And update UI is just going to take our quest UI, and it's going to update that quest list. Then in our base quest, in the start quest event still, we get our objectives. From there, we get our sub-objectives, and we do a for each loop over those so that we bind to the completion or the updating of every single one of these. So the way we do that is we bind to update objective, and then we also bind to finish objective just to be sure. So let's update objective event or something like that. And we just call on quest updated with this. And at the end of the for each loop, we also call on quest updated because now the quest is completely started to initialize. So that is when we want to call out quest updated once fully. This also needs to be hooked up to this objective event. That's my bad. So that it can be added to our UI. And the last things we need to make all of that work is to go into our base objective and going into activate objective and adding a call update objective. So just update objective and call that out so that whenever we activate any individual objective, it also gets sent out as an update because, of course, activating it means we've changed some data about it, which means that everything listening out for updates needs to be aware of that. And then in our quest component, we have our quest complete, where we move the quest that we just completed from the active quests into the finished quests, but there's nothing that's really like broadcasting that as an event. So we're just going to get our quest UI variable and update quest list from that to force it to update the quest list after we change a quest from one list to the other one. And that means that we have a quest thing. I enabled the progress bar for the topmost quest that will set your first quest, walk into the circle, walk into the ramp, and then we need to walk up the stairs, and then it's added to our finished quests instead. Now, the progress bar doesn't quite work yet, and that is because in our objective collection, I don't think we are actually overriding the get completed percentage. But that's actually very easy to do. So instead of using our parent function, we're going to write a quick little implementation for this, where we will get our sub-objectives, we will for each loop over those, and for each one of those, we will get the completion progress, and we will be dividing that by the length of our sub-objectives array. So we can just get length, divide that like this. You might want to put a toFloat node in between just to be sure. The return node here, we're going to just put away for a moment. And then we'll make a local variable called the complete rate. And that's going to be a float, which we're going to set to the complete rate plus whatever the result from that calculation is. So this way we get the completion percentage from all our subtasks, which will get that completion percentage from all their subtasks and so on and so forth. And then we divide them by the amount of subtasks that we have so that it only gets to 100% or a value of 1 when all the subtasks have all their subtasks completed. So we do completion rate plus the result of that is going to be our new completion rate. And then once the for each loop is completed, we will return the completion rate value. And that's the only thing that we needed to make the progress bar work. So now we can see as we progress through our quest, our progress bar will update in increments of 1/3. And then when it is completed, we get rid of it because we don't really need it anymore. That's been a long and in-depth video about making our tree view. In our showcase here, we have these little icons here. So there's a little arrow icon that becomes this downward arrow icon. And whenever something is not collapsible, it just has a little dash. Let's implement that real quick as well. We're going to do that in the quest text, and there's gonna be quite a bit to do here. So let's try to make our way through this really quickly. So we first want to check whether or not our objective is a objective collection. So we're going to cast to objective collection because we're going to do this in 2 separate ways. We'll take our objective name and we're going to disconnect that real quick because we're going to be making a variable for this instead. And the variable that we'll be making will be a text to display, which can be a text variable, that's fine. And we'll add 2 different setting nodes for that. So if the objective is not an objective collection, what we'll just do is we'll get the objective name. We will make a string out of that real quick. So we do a toString so that we can append it. And what we're going to append it as is the A value will be a minus sign and then a spacebar. And then the B value will just be the name of our objective. And then we can do a toText string again to set that as the text. You can just make this a string variable as well if you want to. There's no real use in making this a text variable, but in the end, it doesn't really matter. And then we're going to go to the setText node. We'll do the text to display as the input for the setText node. Now, if this is an objective collection, this is going to be slightly more complicated, but not by that much, honestly. So what we'll do is we'll do another one of these append nodes, where we will append the objective name, but instead of just doing it with a dash, what we'll do is we will get the collapsed state from this thing, and we'll actually use a select string node. So this will allow us to append one of 2 different strings. So if this thing currently is collapsed, we're going to do the little right arrow thing here. And if it is folded out, so uncollapsed, we're just going to do a capital V, because that effectively looks the same. And that's going to go into the text to display if the cast was successful. And then that also goes into the set text. So just as easily as that, and in both of these cases, I guess you also actually want to have some white space next to them. But as easily as that, we now have those little things also showing. So as you can see, this is now by default, everything is uncollapsed. I guess going into the objective collection and setting the collapsed value by default to true might be nice. So now by default, when a quest is added, it is collapsed, and you need to have your input mode set to like UI and be able to click on it and that kind of stuff. But that's quite besides the point. Just it works now. Let's just in the quest tracker add in like event construct. We'll just set input mode to game and UI, and we will get player controller as well. And then we will show mouse cursor real quick, and we'll set that to true, just so that we can interact with things a little bit more easily. And of course, plug it into the set input mode as well with the player controller. It's quite important. And quite important is to select your text and go into its visibility settings and go from visible to being not hit testable, self only. Otherwise, it's going to be blocking your ability to click on the button behind it. And now we can pick up the quest and click on this thing, and because it has the button inside it, it registers our click and uncollapses just like that. And of course, we can just go through, do our quest things. We can collapse it at any time and then uncollapse it, and it will remain with all of its information. If we have any sub collections in here, those will also remember their own collapsed state. So that's been quite a bit for this one video. I might have actually ended up cutting it into 2 videos. We'll see if I can find a good cutting point that makes sense. It's probably just going to be one long video. So I'm going to shut up now. If you want the project files for this entire course, the finished course, of course, as always, has a project file download below for patrons and YouTube members. And each individual episode also has a project file download. With a long video like this, it might be a good idea to take a look at those. With the basic setup of all the quests finished, let's talk a little bit more about the modularity of this system and about other types of objectives. Because so far, the only thing we have is we can pick up a quest over here, and then we get the objectives for the quest. So we do them one at a time, and that is fine. But we only have the one type of objective, which is walk into a trigger box, which is not that good. The whole point of setting up everything in a maybe slightly overconvoluted at first glance way is for it to be expandable. So let's go over a couple of examples of other types of quest objectives that we maybe could set up. Of course, you're free to make whatever kind of objective you want and add it into your quest system yourself. That's kind of the point. I just want to show you a couple of other things as inspiration and as a general guide. So let's go ahead, and in my quest system folder, I'm going to make a new actor, and let's call this something like world pickup so that we can make something with that. And here we can fairly easily just add in, just let's do a cube for troubleshooting purposes, and then a sphere overlap. Make that a little bit bigger so that it is easier to touch. And then on the event graph on begin overlap, we just check whether or not the thing overlapping with it is equal to the get player pawn. And if it is, we run an event dispatcher, something like picked up. So if you want to have a quest where you need to go specifically pick up a certain item out of the world, this is the way that we could do it. So we can just call that out if this is true. And now that we have this actor set up, we can just listen out for specifically this event dispatcher on specific instances as a quest point. So let's do that. Let's add one of these into the world right here. Let's actually add two of them to the world, shall we? And then go into our base objective and create a new child blueprint class, and let's call this item pickup objective. And let's open up the location objective for a reference on how we did things. We did on location reached. After we activate the objective, that's what we bind to. So let's do the same thing for our world pickup. So item pickup objective, we override the function activate objective, which we want to run the parent function on first, and then we want to create a variable for this one, and this is item pickup reference or something like that, which will be of type world pickup, the thing that we just made, the actor. And that's going to be, as always, instance editable and exposed on spawn, so that we can set it right away when we make the objective. And with that, we are going to on activate objective bind to picked up, at which point we just create an event, make a matching function for it, picked up. And here we can just pretty much say we finish the objective. And now in our quest here, let's open up our like little test quest that we have here. Let's add in a second set of objectives. So as I said, we can make separate objective collections. So this is going to be one objective collection for walking to a couple of different places. But then what we're going to do is, just for organizational purposes, I'm going to comment this location objectives. And we're going to make another objective collection. And this one is going to be, let's change the name for this one, explore. Your first quest is now going to consist of a make array between two different other objective collections. So let's hook this up to the return value instead and make one more objective collection real quick. And this one will be gather items. We need to update both of these objective IDs as well. So let's say pick up items, and let's name this one something like first quest. And this objective collection will also be added into here. So the final objective collection that is going to hold our entire quest, I'm going to set to unordered now. And this make array is going to have two pins. The first pin is just going to be our location events. So everything that's in here is still going to be working the exact same way as I did before. The only difference is now we have this second objective collection that we're also putting into this array. And to make that objective collection, we're going to make you pick up two items. So let's copy this over and let's change this to a item pickup objective, which of course does not have the ordered value and all that kind of stuff. So we just refresh the node real quick, and we need a item pickup reference. So we promote that again to a variable. This will be item 1. We'll call this objective ID item 1. Again, you probably want to name these something a little bit more unique, like appending the quest name to them first. And then we just copy that over, name this one item 2, make that a variable as well. I will call that item 2. Both of these are going to be, of course, instance editable because we want to set them in the editor. And we'll just hook everything up together like this. And then the sub-objectives for our collection that's going into the array here, we need to still make an array. And that's going to have the two item picking objectives inside of it. This one, I don't think I want to have as an ordered one, just to have a little bit of variety and to show you stuff. So let's put a comment around this one as well, which you can do by just selecting nodes and pressing the C key, if you didn't know. And let's say this is items to search or whatever. That's a bad name for a comment, but will probably be fine. And that all comes together in this objective collection that is then going to be the entirety of the quest. So now we are back with our test quest, and we can see we have an item 1 and an item 2. which we can use to pick out these two items. So now when we play the game and we pick up that quest, we have our active quest, your first quest, and when we open it up, we have explore, which is entirely ordered. So it makes us go over there first and then there and then there. But we also have gather items, and that says gather items and gather items because we just copied over the text between the two of them. But we can do these in any order we want. So we pick these up and we can see, hey, this item has now been gathered, and going into it again doesn't actually like update anything because it's not looking for any like specific overlap twice. It's looking for specifically a signal from this one and then specifically a signal from this one in either order. So now we can see that that sub-objective collection has been finished off, but to finish off the entire quest, we still need to do the exploration part, which is all this, and then it finishes off the entire quest over here. So that is how we can set up a item pickup objective. Now, next up, let's do something where we can kill an enemy. And for that, we're going to have to set up a very basic, like, temporary enemy blueprint. So let's just make that. And this one we're going to give a sphere just to differentiate them a little bit. And in this one, when we get damaged, which is up here in the event somewhere, any damage, obviously in a proper enemy, you would have HP and you would check if the HP is less than 0 and then kill it. For now, just at the moment it receives any sort of damage or whatsoever, what we're going to do is an event dispatcher on death, and we're gonna call that out and then maybe even destroy the actor if we wanted to. You also, if you wanted to, instead of making a separate event dispatcher for on death, you can also just bind to the on destroyed, because that is a thing that every actor has as well, on destroy. Bind event to on destroyed, there we go. If you want it to be a little bit more generic and not tied to something like an actor class, or maybe having to use an interface that calls anything like this, you can very much just bind to actor destroyed instead, and that does make it a little bit more generic. For now, I think I'm going to do this just for the ease of showing things off. Let's go into our third-person character here real quick. And I'm going to make a debug key. Let's do the F key. I like doing the F key. Where we sphere overlap actors. We set the filter to being the enemy. And the enemy, I assume, is going to have its collision world static. It is actually a world dynamic object, it seems like. So let's make this array. Funny thing is, if you don't make that array, it's going to scream at you because you do need to give in some object types. So let's set it to world dynamic. Get actor location for the sphere position here. This is just a very basic, like, test damage system, to be honest, within, like, let's do 500 or something like that. And now for all the out actors, we're gonna for each loop over them, and we just apply damage, which is a built-in system within Unreal. Doesn't really matter what type of base damage we deal to them, because we're not doing any math here. We just, whenever we receive any damage, we just call out the on that. And now we can go back into the base objective again. We can create a child blueprint class, enemy kill objective or something like that, where when we activate the objective, we search for a enemy reference, which is of course going to be a enemy object reference. As always, instance editable and expose on spawn. And then we bind to the on death event. And at this point, you kind of get the gist, I am sure. We create an event. We create a matching function. Let's call that onKilled, which is just simply going to finish our objective. And let's do something a little bit funny here. Let's make that into a separate quest that unlocks when we finish this quest. I think that'll be a fun little, like, change to throw into this too. So let's just copy over task quest for now. That makes task quest 1. Let's call this kill quest. And this is not going to have the location triggers and all that, of course, because it's going to be an entirely different quest. This will have a handful of enemy object references instead, because we have to kill specific enemies. And then here in init objectives, we can get rid of all of this. Let's keep one objective creation node around, just because it's easier to be able to copy them over. And we can move all this back in a little bit to have everything closer together. Make array, of course, for the objective collection. And let's also just do 2 of these. So this will be enemy kill objective. Of course, for both of them, then we might want to refresh nodes because they have input pins that we don't need. And we just hook up the enemy reference 1 and 2, which are still called item 1 and 2 actually. So let's call this target 1 and target 2, just to make sure that things are a little bit more descriptive. And then we hook these up to right over here. And just like that, we have our second quest. So we can just drag in the kill quest, set up the targets that we want to kill. For that, we of course need to actually put in the targets into the world. That would help quite a lot. So let's put one over here and then one all the way over here or something. And let's try to pick those out again. I almost forgot though, do make sure that these quest IDs, again, for saving purposes mostly, but these quest IDs for the objectives need to be unique. So let's call them kill 1 and kill 2. And now we can do something a little bit funny. Because if we go into the level blueprint for this level, we already have our test quest 1 reference here. I just highlighted our new quest, so I can make a reference to that as well. And what we can do is on begin play, using test quest 1, we can bind to quest completed, because that is a event dispatcher that we made. And if we then just make a custom event, we can then get the player character or player pawn or whatever. In either case, we use our get quest component interface for that. And with that quest component, we can add a quest. And the quest that we're going to add is going to be the kill quest. So now when we finish our first quest, our second quest will automatically be unlocked and started. Of course, that can potentially be an issue with specifically objects that can be destroyed. We'll talk about that in a moment. Actually, let's just do it right now. If I press this, one of the objects that we're going to be looking for will have been deleted already. And that might be a problem. So the best way to do that is to just only either like make these active or just spawn them in at quest activation instead. So we can go into our enemy blueprint, for instance, and on begin play, we can set actor collision to not being enabled anymore. And then also set visibility or set actor hidden in game. That's even better to being true. And then in the enemy quest objective, when we activate the objective, we also want to just go into our enemy reference and set both of these things to the opposite value. So they're no longer hidden and they now do have a collision. So they automatically get activated when they get relevant to the specific quest. Which you'll see, they don't show up now. I can actually just walk through where they exist, and only when that quest starts up will these become visible to us. So let's finish our first quests here, which of course is gathering these items, which is one of our sub-objectives, and then we can do the exploring bit of the quest, which allows us to get the new quest, which has bad text because I didn't set the text properly. But you can see now the actors that are supposed to represent our enemies have spawned in. So I can kill them and progress with this quest, which will then be added to our finished quests as well. I apparently made this a horizontal box and not a vertical box. That's my bad. It should be a vertical box. I want to do one last example just to show things off a little bit, and that is going to be making something that doesn't necessarily require you to bind to very specific things. Because right now, we can bind to these locations, or these specific actors, or these specific actors, and wait for a certain action to be performed on those specific actors, which is very powerful and very good, but still, you might want a quest where you check, hey, have you gotten a certain amount of items, for instance, right? And that becomes a little bit more complex quite quickly. And in order to properly show that off, I would need to import an inventory system into this project, which I don't really feel like doing. So we're not going to get very complex, but I'm going to do a very quick like mock-up inventory system real quick to show you something that might work kind of like how you would set that up. So really, really quickly, I'm going to speed through this. If you do want an actual inventory component and an entire system, I have an entire like 2 playlists for that as well. So don't you worry about that. For now, we'll call this invcomp. The inventory component will have an item added. I will make a primary data asset for the item class. Then we'll make a data asset based on the item class. So that'll be item 1. And we'll copy it over for item 2. Actually, we need to duplicate it, item 2. So we have 2 different items now. I'll make a structure for the inventory slots, which is going to have the amount, which is of course going to be an integer, as well as the item, which is going to be an item class object reference. Item class is a bad name for it, but again, I'm kind of speeding through this. The inventory component will have an array of items. So let's make that the inventory slot structure as an array. We'll make an add item function, and that will also call out the on item added. This is the kind of funny thing though, is if we go back to on item added, we do want to broadcast which item and which amount of item. So we just want to create an input here for the added item, which is just going to be the structure that we made. So we can pass that right through. And now whenever we add an item, it's going to add the item and broadcast to any listeners, which could be quest objective objects, what item was just added. So now we don't need to bind to the specific items that we want to pick up. We can set something up where we can specifically say what item we want to be looking out for. So let's create that. Going back into our quest, base objective, create blueprint class, item, gathering, objective. And this is going to be a little bit more involved. There's going to be a little bit more code added now than just binding to one thing, because we need to write a little bit of logic on top of it. And this is really starting to show how powerful an expandable system like this can be. So when we activate objective, what we're going to do, the very first thing is we need a reference to the player's inventory component now. So we're still going to be binding to an object in much the same way. So let's bind to the inventory component, and that'll be the specific inventory component that we're going to be watching. So this will theoretically even scale with multiplayer games, because you're going to specifically be looking at one specific inventory for every instance of this quest being started. Anyway, we make a variable of inventory component, which of course is going to be exposed on spawn and all that kind of stuff. There we bind to on item added, where we create a event. We make a matching function, which has the added item. And here we can start doing some fun stuff. So we can break this slot, and first and foremost, we can check whether or not the item asset that we just got is equal to, let's promote this to a variable, the item to look for, or something like that. So now we only will progress if the item that we picked up is actually the item that this quest objective is telling you to get, which of course is going to be instance editable, expose and spawn. Everything essentially you add in these objectives, you need to make instance editable and expose and spawn. So let's make another variable as well, which will be the amount of items that we want to get. So the amount to get will be a integer, which will be instance editable and expose to spawn. And we're actually going to get another integer right here. And this is the amount gathered. And this one doesn't need to be set to any sort of expose and spawn or whatever. This is just what we're going to be incrementing to keep track of how far along we are. So if the item we're looking for is the same one that we just picked up, we set our amount gathered to being our current amount gathered plus the amount that we just picked up. And then at the very end here, after we figure out how many we have gathered, we can check if this is equal to or greater than or equal to, it is actually the amount that we need to get. And if it is, we can finish objective. But if it is not, we still need to update our objective, because it now has a new amount of completion or progression. So we still need to call update objective with the objective just being itself. Now, since we are making something that requires some more in-depth calculations, because now we have potentially like picking up 15 items or 20 items, we also want to go into our get completion progress and overwrite that as well. Because now what we want to do, if you want to get the amount we have gathered and divide it by the amount to get. Quite relevant though, is that we want to make these into floats before we divide them. Because if you divide an integer by an integer, it can only result in an integer, which means that you don't get a decimal place. So we want to get a 2 float for both of these first. And then the amount gathered, we're going to divide by the amount to get. And this is going to update every single time as well for things like a progress bar. So let's go back into our killing quest and set up a second set of objectives here as well, just because it's the first quest that I had like right at me, to be honest with you. Let's call this your second quest. Objective ID I'm going to set to quest 2 and so on and so forth. We have to kill these things. This doesn't need to be ordered. let's construct a objective collection for the killing things. Objective name, kill them all. Kill quest for the objective ID, that sort of thing. Let's make these ordered, just because, why not? I like showing the flexibility of the system, that is why. Hook these up to there. This is going to go into the objective for like the final output. And then we're going to make one more objective for the final output, and that will be our item gathering objective, which, of course, let's refresh nodes to get rid of that like weird little input. That's going to require us to get an inventory component. But since we're just in a kill quest actor here, which is an actor, we can very easily just get player character. And ideally you would have a interface set up to get the player character's inventory component, all that kind of stuff. For the time being, I'm just going to cast to our third-person character blueprint to get the inventory component we haven't even added yet. Hold on. Let's add an inventory component. Invcomp, there we go. Now we can get that inventory component. Make sure that you compile the player blueprint before trying to get this, otherwise it might not show up. And then we can just choose the item to look for in this list here. Item to look for does seem to be a normal object reference. So let's actually go back into here and make sure that this is set to our item class object reference, because now it'll just show up with drop-down menus for our items. So I want to gather, let's say 15 of item 1, get grass or something like that. And then for item 2, I want to gather just 5, get rocks, I don't know, something like that. Grass for the objective ID and then rocks for this objective ID. And of course, as usual, we make that into an objective collection with make array. Set both of these up like that. We want to make sure that these are not set to being ordered either, because I want to be able to gather these items in any order that I want. And then our objective collection is going to go into this array to make this other objective collection. And now we have our like nested quest set up all good again. I make sure that the inventory component is hooked up to both of the objectives though. And for these, I think it makes sense to show progress bars as well. So let's make a quick little actor for item pickup as well. So this can be item pickup. And this one, I will also make a sphere, but I'll make this significantly smaller, something like 0.2. And then we will give this a sphere collision. And then on begin overlap, we just check whether or not the thing that we're overlapping with is equal to the get player character. In this case, actually, since we need to do a cast anyway, we might as well just do it with the casting method. So cast to third person character, because we need to get the inventory components, because we're going to be using the item function on it. And the new item that we're going to be adding will be a variable here, item on a per instance basis. And then the amount to add, for now we'll just set it to 1, but you can also make that a variable if you really wanted to. And let's say we place this down here. We say that this is item 1, and we just like place a bunch of these things around. So this is like 6, 9, it will be like 12, and this will be 15. Is that right? I think that's about right. And then let's add 5 more over in this direction over here, and these will all be item 2. So I think that should have updated them all at the same time. Yeah. So we don't need to link these specific item instances or anything to our quest, because the quest is just going to check whenever we update our item inventory at all, whether or not it should update itself based on what we just picked up. That said, the way we set this up now doesn't take into account any of the items that we might already have inside of our inventory when we start this quest. If you want to do that, you need to have your inventory system a little bit more built out with like proper inventory querying set up to work. This is a fairly simplified version. Again, if you want a good inventory system, I have 2 full playlists going over the basics and then some more intermediate stuff right here on this channel for free, so you can watch those. And now we can do the same boring quest that we've done about 1,000,000 times at this point, walking around the map, picking up all our stuff around here, and then unlocking the second quest, which has the killing objective, which now is enabled, of course. It seems like it maybe didn't enable the second one this time around. That's worth looking into. But more importantly is the getting grass and getting rocks. So all these things are grass. I actually just realized I didn't set them up to destroy themselves when we picked them up, so they're not going to disappear. But they will, every time I collide with them, increase the amount of progress that we made in this quest. And when we get to picking them all up, or as many as we need anyway, we have finished up that objective. And that is for those items. These are the rocks, of course, which we only need 5 of to complete this objective. And now our quest item gathering has been fixed up. So that is a slightly more in-depth kind of objective where you can start seeing how this quest system can very much hook into other systems that you have, as long as those systems broadcast their events through event dispatchers. You can easily hook into them. So that's been a fun little overview, a slight detour, just widening the scope of what we can do with this quest system a little bit. And the interesting bit is that these will, in theory, still keep counting up even after you have completed the quest. So if you make a quest that says, hey, gather 15 of these items, and then it unlocks the next objective, like go back to the person that gave you the quest. When you get back to the person giving you the quest, you can then check the objective for gathering the items on how many actually ended up being gathered. And if it is over a certain like secret higher number, maybe that can include better quest rewards. And I think that's actually a fun idea to explore in a future video. It's setting up quest rewards and maybe doing a kind of like a grading system. Having a base set of rewards, but then if we have reached a certain amount above the task that we have been assigned, we get a different reward or maybe a better reward or whatever. So let's take a look at that the next time around. What is a quest without a good reward, eh? So let's take a look at rewards. And while we're at it, last time we set up a nifty little quest where we didn't even actually need to bind to any in-world object or anything. It's just keeping track of item gathering for us. And I think that's actually a pretty good way to set up something like item gathering grading, for instance. So if we need to collect 10 items, but if we come back, haven't collected 20 items, maybe the quest reward that we get should be increased. So let's take a look at that and see how we do. First though, we need to set up a basic rewarding system. So what we're going to do is we're gonna go into our quest folder over here, which is getting a little bit full. You might want to like organize this a little bit better than I am at the moment. And we're gonna go into our base quest, because here we have our basic setup here for starting a quest, which inits the objectives, it binds to finishing the like final nest of the objectives, and then it calls the on quest. We're gonna add some stuff into here. So you can actually add whatever you want into here. For the time being, what we're gonna do is we're just going to set up something simple where we gain a little bit of gold, because that's literally just a float that we can update on our player character. Of course, if you have an inventory system, you can hook this into having certain items be rewarded to you or whatever. Again, the thing with the quest system is that it so much would hook into whatever the rest of your game is, that it's kind of difficult to show some portions of this properly in a standalone project like this. But the possibilities are quite literally endless. So let's add a variable for money. We're going to be printing that out on every frame, effectively just. That's going to be a float. And for troubleshooting purposes, I'm just going to add in a tick event, which will have a print string, and that print string is just going to be the value of our money, and the duration is going to be delta seconds, so that's only ever going to be print 1 at a time. Quest completed. In this case, what we're going to do is, in the base quest, I'm actually not going to do anything. You can set things up in the base quest, like just have a variable of the amount of money that we're supposed to add, but since the entire point of having this entire quest system be object-based is for modularity and scriptability on individual quests, what might make way more sense to do is going into any given quest, like the original like test quest that we have here, and going to our on quest completed, which is a event that we have here. Important is always when you call a event like this in a child class is that you also add a call to the parent version of it, because the parent version of it is actually the thing doing the call out of, hey, the quest has been finished. Aside from that though, we can just kind of get player character in this case, and we can fairly easily just cast that to our third person character here to get our money. And then we also set our money to money plus, let's say, 50. So now when we finish this quest, we're going to go from 0 money to 50 money. So let's just first and foremost, before we do anything else, check if that works to begin with. So we unlock the quest, we have 0 money, as you can see here up in the corner. It's a little bit small maybe, but trust me, it says 0. So we finish off the first part of this quest, which again, you can see through the quest menu. Then we gather up these items, and now boom, we have 50 money. We got a reward for our quest, which is all fine and good, but this video will be very short if that's all there is to it. Obviously, we could also fairly easily set up something with the inventory component, so we can get our inventory component and add an item to it, and the item that we can add can be anything, really. Any item that you have in your game can be added this way through adding it to your inventory. Of course, if your inventory has a limited size, maybe first you want to check whether or not it fits in the inventory, and if it doesn't, you might want to like flip a ball for the items not having been claimed, and there's a whole bunch of like logic that you can add on top of this, which is much more to do with the inventory systems that you might need to build than for this specific quest system. But just know that it is really easy to just expand this into anything that you want. Do you want to unlock a new skill and you're using the gameplay ability system? You can just add an ability to your player character's ability system through this. Do you want to change something in the world? After a quest has been completed, you want a certain wall to break down so that the player can progress with the rest of the game. Do you have like an event flagging system for your game, which is usually just a list of rules for what has and hasn't happened yet, so that other parts of your game can read in and see if something has happened yet and adjust their behavior accordingly? You can do that in here as well. You can literally script out whatever you want for any specific quest, because every quest in and of itself is its own blueprint actor with the power to implement its own logic. Now, I'm sure that you're already going crazy with creative ideas in order to like implement any of this, but what I want to do is I want to talk a little bit about grading potential quests, because that is where it becomes much more interesting. What we can do is let's go into our kill quest over here, because here we have this. Let's do this one, right? We are gathering the grass item, which in no way is even like representative of grass in any way, but hey, we're gathering it apparently. So what we probably can do is we can promote this to a variable so that we can read it outside easily as well. So this will be our grass collection. And the reason that we're promoting this to a separate variable is because this task, as we built up last video, itself keeps track of how many things we have gathered. So when we eventually now get to the quest completion, just in a normal event graph, so complete quests, we can check, hey, this grass collection, we can get the amount gathered, and we can do some logic based on this. So if the amount gathered is just, if it is less than 20, so that means that it is between 15, which is required to even get to this place in the first place, but it's not yet 20, we just give it the normal reward. So what we do is we cast to a third-person character, which we actually need to do that with get player character first. So get player character, we cast to third-person character, all that good stuff. Of course, I almost forgot, you also need to add in a call to the parent function, otherwise the quest itself won't be marked as being completed. But after we do that, we can then get the money and set the money, and the money will be equal to our current money plus a certain amount. And now that certain amount, you can do this with a bunch of branching nodes. What is also nice to do is to do it with a bunch of selection nodes, because that requires less execution pins and that's less of a mess. So let's make this into a select float. So the base amount of money that we're going to get for this quest will be 100 money. But if we, and that happens if this amount gathered is indeed less than 20. But if it is not less than 20, which means that it is more than 20, we're going to get, for instance, 200 money. But we can expand this as much as we like. So we can also say, hey, the amount gathered, we also want to check if it is less than 30. And we just add in another select float node into that as well. So here we check if it is less than 30. So it's going to first check, hey, is it less than 20? If so, it's just going to pick this one. But if it is more than 20, it's going to pick from one of these. So this will be 200, but if it is over 30 that we've picked up, we can give like 500 gold or something like that. And again, you can make as many of these select float nodes as you want, or you can just do something similar and add in a bunch of branching nodes with separate setting nodes as well, whatever you prefer, really. I like doing it this way because it doesn't muddy up my entire event graph with a bunch of execution pins. And as a quick little aside, this is also where the expandability and descriptability of this entire system comes into play. Because while we can just check for the state of any of these objectives that we are displaying, there's nothing to stop us from actually making an entirely separate objective, like killing an entirely separate enemy, and just not adding it to this objective collection, meaning that it's not going to be displayed, it's not going to be required for finishing the quest, but it is going to be a thing that you can do. So if you have a set of enemies that you can kill, but then you hide an enemy away in a hard to find place, and if that enemy is also killed, then you get an extra reward, right? We don't add this to any objective collection, we simply promote this to a variable and call this extra enemy kill. And you would give this an enemy reference and whatever. We're going to skip over that for now. And then on the quest completion, you can get the extra enemy kill and you can get whether this separate secret objective has been completed or not. And then do some reward stuff with that. And just for testing purposes, what we're going to do is in the item gathering objective, anytime that we pick up anything in here, I'm actually going to print string real quick, which says it requires a world context object. You can just kind of leave that empty between you and me. And we're going to print out the amount of things that we now have. So unfortunately, I have set this up in a way where I need to do the first quest in order to get to the second quest. So maybe I should swap those around just for the sake of my own sanity, but it's fine. We can now get to the second quest where we can see this should not be printing out. Oh, it actually is printing out 15 across the board. And that is because I am printing out the wrong number. I'm printing out the amount of get, not the amount gathered. That is my mistake. But you can see, even without the word context object, it has no problem printing out the values. And now that we're back here, second quest, we will see that it prints out 1, 2, 3, 4, and so on and so forth. Once I finish running back and forth over these, it will keep on counting. It doesn't show me any more progress, and it says the objective is finished, but the objective is still actively listening out for anything happening that might regard it. So we can go up to 25, for instance, and then if we finish off the rest of the quest, we can like get rocks, that's fine. So we can try to kill these things, and that is entirely possible, even though for some reason. Let's just go with it. And that should now reward me with 200 gold because I went above and beyond to finish this quest. Now, if we do all that again, but this time I pick up 30 of this item, which is going to take a little moment. So just give me a second and we'll have 30 soon enough. I'm certainly very glad that these things don't destroy themselves after I pick them up. I'm specifically checking for more than 30 at the moment. So with just 30 picked up, that is not enough. I need to pick up at least 31. Now, I do want to point out that this progress bar is entirely filled up, even though we haven't done the getting of rocks yet. And I will address that in a moment, because I actually didn't think about that until this very moment. Let's fill this up, and we now have 500 because we went over 30 items together. So we now have a grading scale for different quest rewards, depending on how well we did. And of course, again, you can track multiple objectives with this and make like a weighting system to decide like, okay, this quest needs to have this grade at least, and then this quest needs to get that far in order for rewards to be improved. Like, you can get fairly deep and fairly complex and advanced with this. Now, the issue with the progress bar is that in our get completion progression, what we're doing is we're dividing the amount to get by the amount gathered, or the other way around, actually. We're dividing the amount gathered by the amount to get. But if the amount to gather is higher than the amount to get, this is going to give a value over 1. So while that is probably nice and good, and that can be a potential way to track how much you've gone overboard instead of using like the hard-coded systems that we did, you can also just check the completion progression of any given event item and check if it is like at least 2 or 3, which means that you've gone 2 or 3 times over what you actually needed to do. So this can actually be really useful. So the easiest way, I think, to deal with that, because I do like this idea of keeping this around, is to go back into our base objective and go to get completion progression. And here we can add new output parameters. So What we'll do is we'll keep this one, change its names to completion rate clamped, and then we'll just make another one, which will be the unclamped completion rate. So this will be completion rates unclamped. That's maybe a little bit wasteful in some regards. In the default implementation, it's just going to be a 0 or 1 kind of thing. But for the most part, everything that we have set up before is going to use the clamped version. But now that we have this set up, we can go back into our item gathering objective, and we can say, okay, this is going to go into the unclamped. And then we will also clamp this float between 0 and 1 for any other purposes that might require it. Otherwise, you would need to set up a clamping node at the other side, the receiving side of this function. And we have a bunch of places where we use this function. So then we would need to set up clamping on each one of those. Potentially, you could also combine these into a struct and just send through one entire struct. You can really do whatever you want with it, to be honest with you. So as you can see now, for instance, here in the objective collection, it's using the completion rate clamped to calculate everything. And then we will return our completion rates clamped and unclamped. You can even keep a track of an unclamped total in the objective collection if you wanted to. That might actually be kind of nice. So let's do unclamped completion rate as well, which is going to be a float, and we'll set that in much the same way. So we'll get our current value and just add the one from the function's return, and at the very end, and then divide that by the length of the array so that we normalize it on a 0 to 1 scale. Of course, this is going to potentially be over a value of 1, but that is kind of the point. And then we can use that as a return value for the unclamped value. So that is our way to deal with it. If you want a more generalized, just how much percent did I get over the entire quest or over a specific objective, and just like use that as a multiplier or something like that, that is entirely fine. Of course, I personally do prefer kind of just like saving out the specific objectives that we're looking out for, and then using them to figure out the exact data that we're looking for, and like setting up these selection nodes or doing some logic based on that. But having the power to do either or both, between more generic, just getting a completion percentage over 100%, or doing some more custom scripting stuff like this, is probably a good thing. So having both as options available to you hopefully will be helpful. We have set up completion rewards for the quest now that will even grade accordingly to how much you overperform. So we really have quite a bit of this quest system set up at this point. A major thing that is still missing though is the ability to save our progress in said quests and use that to carry quest data between different levels. Our quest system is effectively functional. The only thing that we need to be able to do is to be able to carry data between levels, because maybe you want to pick up a quest in one area and then actually do part of it in another area. Maybe even you want to make quests that need to be completed in a couple of different areas together. That can be a little bit more complicated. And of course, we just want to be able to, in general, save our progress with our quests. So today we're going to go over a save system that will allow us to do all of that. And to get started, I'm going to do this in the game instance. If you're following along in something like C++, you might want to make a game instance subsystem instead, because that way you don't have to overwrite the game instance itself and it doesn't cause like conflict with other systems you might have. But for the most part, a game instance should be fine. So let's make a game instance. We'll call that something like quest GI for game instance. I'm going to open that up and we're going to go into the project settings real quick, and in there find the game instance and change it to our quest game instance. Before we actually do any programming in there though, we're going to go back into blueprint classes and we'll make a save game as well. And this is going to be our quest save. Let's open that up too. And in here, we're going to make two sets of variables. First and foremost is going to be the completed quests. These are just the quests that are entirely completed, and we don't need to worry about saving any like minute progress on. It's just a string that's going to tell us, hey, this quest ID has been completed. If you find the quest with this ID, just mark it as being finished. So that's pretty straightforward. That's the reason that we're giving quests individual IDs, so that we can easily identify them by that ID. Then we're going to go into blueprint and then into structures, and we'll make a quest save data structure. Let's open that up. And in there, we're going to put the quest ID so that we know what we're talking about. So this is just going to be the string. And then we're going to keep track of the progress of the quest itself in a map. So it'll be a string map with values of floats. So this is going to take in our quest IDs for comparison reasons, and then it's going to check the progress on each individual objective within that quest and store its progression value. So the 0 to 1 value, maybe sometimes more than 0 to 1, we'll get to that. That shows us how much of a certain quest has been completed. And once we've made that, we can go back into our save object and we can make our active quests. And that's of course then going to be an array of type quest save data, the struct that we just made. And you'll be able to see, just as an example here, if I make one, it gives us a quest ID, and then the progress is a map of strings and values. So that's a lot of object setup, but now we can get into the fun part, and that is making a whole lot of functions. So let's go into our quest game instance and start by setting up a event initialize. Whenever we initialize, we want to create a save game object immediately for our quest save. What we're going to be doing is we're going to keep a copy of the save game object in memory at all times, so that we can dynamically pull information from it and write information to it. And then when we either save or load, we just use that version in memory to write to disk or read from disk into that thing. That way we don't have to make a gigantic function sometime down the line when we want to save a bunch of information. We can just, whenever information changes, we send it through to this object, and when we then actually want to save it, we already have the most up-to-date information in the object, and we only need to write it to disk. So let's promote that to a variable, and that will be our quest save. Let's make the saving and loading functions for it first, because they're very simple. It's actually going to be as simple as making a custom event, save quest data. And you won't believe how simple this is. This is just save game to slots. And since we already will have an object that has up-to-date information, all we need to do is get our save game object that we created here. And we're going to be continuously populating with new information during the gameplay, and save it to whatever slot that we want to save it to, which is going to be an input parameter for this event. And that's all there is to it. We don't need to set a bunch of values at the moment of saving, because we're constantly doing that during the gameplay. And then we'll make a custom event, which will be load quest data. That's going to check if a save game with a certain slot name exists. And if it does, it's going to load that game from slots with, of course, that name. We then cast that to the quest save that we just created. And with the quest save, we're just going to set the reference that we create up here to whatever we just loaded in from our slots instead. So we overwrite every data about it. So these are two quick and easy functions that you're going to want to have anyway. Now we need to write all the functionality that allows us to update the information in this object dynamically, constantly, for these two functions to actually do anything. So let's get started with that. And the first one of which is going to be a custom event, which I will call update quest data. So this is going to be an event that just updates all the quest data from your current level into the current quest object. And the first part of that is actually going to be fairly easy. We just get the quest save, and then we also go into the input parameters for the event, and we make a quest component, which of course is going to be of type quest component object reference. And that is just going to get the finished quests. We're going to get the keys out of that. And in our save object, we're just going to set the completed quests to those keys, because we already have this map that contains all of the IDs of all the quests that we have finished. So we can just directly set that. It's just as easy as that. Now, the next bit is going to be slightly less easy, because we can't simply override the map for the active quests with whatever we have at that time, because the map of quests that exists that are active in your quest component will only be the quests that are in the level that you're in at that given time. So instead, what we need to do is we need to take all those, check if they already exist in our save data. If so, overwrite them. And if not, we need to append them into that list, which is just a bit more tricky than simply doing a quick override like this. So for that, let's go into the quest components, because we need to get the active quest data out of this. So we make a function, get active quest data. And this is relatively straightforward, all things considered, because we can just get the active quests, we get the keys out of that, and we for each loop over those keys. Make sure everything is hooked up. Then for every one of those keys, we're going to find the corresponding object, which is always going to be valid because we're getting it from these keys. And there we need to get the base quest to give us the progress on its objectives. So let's open up our base quest right over here and add in a function for that. So get completion objective progress, maybe something slightly more descriptive in a better way, but for now, that'll do. We get our objectives, which is our main objective collection, and from that, we get the completed objectives. We kind of misnamed this. As the series has gone on, I've realized that things that we set up in the beginning, in the very first video, to do with the string arrays are going to need to be converted to the maps, but we'll worry about that in one moment. Because in the end, we're going to be returning just a single piece of quest data. Make an output of type quest save data, and we'll just call that quest data or something like that. So now we need to go into the get completed objectives function, because at the moment that is returning just an array of strings, and that is going to need to change. So instead of returning an array of strings, this is going to return a map of strings and floats, which actually simplifies some of this quite a bit, because instead of doing this make array and this is complete, what we're actually going to do is we're going to just have one single return node that is going to be making a map. And the map that it's going to make has one entry, which is the key with the objective, and then the get completion progress. And we're going to be saving the unclamped version, because if we go over the amount that we're supposed to get of something, we actually want to be able to save that progress, of course, because that can mean that we get a better reward. Because we want to be overriding the get completed objectives in the objective collection, because here we're going to need to change the implementation a little bit as well. We get the sub objectives and we for each loop over them, of course, as we so often do. And then for each one of the sub objectives, we're going to get the completed objectives, which is the same function that we're working in right now. Maybe changing the name of this function would make a little bit of sense, but for now I don't really care enough. We'll get the keys out of that, and then we for each loop over each one of those. Then the return node we can right click on, promote it to a local variable. I'm just going to keep this as a new local var for the time being, because I really don't care about what it's called. And in this for each loop here with all these strings, we're going to be adding every single thing. And this will just take in the string from the for each loop. And then what it'll do is we'll take this map, we'll find from it that same string from the for each loop, and we'll put that in as the value that we pass into the map. Well, we do that for like this for each loop inside of this for each loop. And at the very end of it, it's going to have a full map of all the sub-objectives with their completion percentage. So that now allows us to finally go back into our quest component where we left off. After we find in our active quests the object, we can finally now get the completed objective progress, which gets us one pin of quest data. And let's make sure that we have that finished up as a function. Oh, we actually don't. Good thing we checked it. So for the output, we'll make it. And we'll make it with the quest ID and the output map from this get completed objectives function. And then finally, back in the quest components, now that we have checked that everything is implemented properly, we add a return node here so that we can add an output, which is going to be our active quests. And that's going to, of course, have a value of quest save data. And it's going to be an array, which will populate on the completion of the for each loop. I will promote it to a local variable. We'll call it quest data. And inside of the for each loop, every time we go through, we just add to it whatever output comes out of this quest base. With that, we can come one step back out again into the quest game instance. And there we can finally use our quest component input parameter for the update quest data to get the active quest data as an array out of there. Now, We just set up everything to provide its data. So that is a huge part of this system done. Now we just need to add that to this object, which is not entirely super straightforward, but it is going to be okay. At least we don't have to jump from class to class as much for this one. So for this one, we're going to go into the quest save and make a function in there. And we'll call this something like add to active quests. That's going to take in an array of quest data, of course, because that is the entire reason why we just jumped around so many classes and fixed up some things there, to get all that data into a single array to pass into this function. So let's call this new quest data. And there's going to be quest save data. It's going to be an array. And we're going to for each loop over that array. And this is actually everything we need to do in this function, because we're just going to run an entirely different function on each element of this for each loop. So let's make that new function, and we can call this something like single quest data. This is not really meant to be used in an individual basis from like outside from any other objects or whatever. So what we're going to do is we're going to go here into the access specifier and set it to either protected or private. If you plan to make child objects of this, this might be relevant to be able to access in child objects. For the most part, I think you should mark this as private. You don't want to get confused and accidentally call this on something or whatever. This is only going to be called from to active quests. And of course, this is then also going to have the same input. So let's call this new quest data as well. And that, of course, has to be a singular variable instead of an array. Now, this is going to be a slightly tricky one. So what we're going to do is inside here, we're going to take our active quests variable that we have on our save object, and we're going to for each loop over this. Now, I do need to warn you that what we're doing is we're for each looping over the data that we're getting given in. And then for each one of those loops, we're doing an entire loop over everything that is in our save object. That's going to add up quite quickly because, spoilers, there's going to be another for each loop at the end of this as well. So we're going to do very quickly going from tens to hundreds to thousands of operations within a single game tick here. So don't call this during gameplay. This is a thing that you call at the beginning or the end of loading a level, or when you specifically need to update your quest save data because you're like saving it to slots and you need to make sure that you have the most up-to-date information. This is not the type of function that you call every single time you gain a new quest, because every single time you gain a new quest, beyond a certain point, you're gonna really experience a momentary frame dip because of it. It's gonna do quite a number on your CPU when these lists get quite long. Now, that said, let's split this structure pin because we don't actually need it as a full structure pin. And the first thing that we're going to do is we're going to put in a branching node. And we want to check whether this quest ID from this for each loop that we have is exactly equal. So that is 3 equal signs, not just 2, but 3, to the quest ID that we get out of the input parameter here. So we want to check that. Because if we are checking against a quest that has the exact same ID, we're checking against the same quest, which means that we have found the quest that we want to update in our quest list. So after this, we can cancel out of this operation to save ourselves looping over things that won't be relevant anyway. So if we find that, we can get the keys from this map up here, and then we can for each loop over every single one of those. So this is the last for each loop we're going to go through. And here we need to do something a little iffy, and that is we get our active quests from this variable array, and we need to get a reference. Do not get a copy, get a reference, because we're going to be actively updating the data inside here. If we get a copy, it doesn't actually update the data inside the array. Copies are good for reading, they're quick. References are for when you actually need to change the actual data in the array itself. So that's why we're getting a reference, and then we break that reference open as well, because we're going to need to get the progress here, and we're going to be adding some stuff to it. The great upside about a map is that it doesn't allow you to add the same key twice. If you try to add something that's already there, it's just going to overwrite the corresponding value, in our case a float, with the new value that you're given in. So we're just going to be adding the objective ID, which is what this is, in here, and then we need to give it a value. And this is kind of where we get to a little bit of a question as to how sophisticated you want and need this to be. Because if you are in a level and you leave it and you go into a different level, you probably won't have to worry at all about overriding this progress. Because the objective isn't going to exist in that other level. So when we try to like write our objectives to this thing, in theory, it should leave any objective that doesn't exist in the level that you're currently in alone. It shouldn't overwrite that. That said, there are edge cases where this might be relevant, and that might actually end up happening. Specifically, if you have a quest ID with also an objective ID that is shared between two different levels, that might be relevant, especially if you're doing like gathering quests that are valid in a couple of different levels, that you want to be accumulatory in their progress. This kind of thing will pop up. So just to be sure that that is all dealt with and okay, what we're going to do is we're going to get this map reference over here, and then we're going to use a find. And then we're also going to use a find this map reference that we have over here. And we're going to be finding the exact same value. And it's a little cheesy, but we're just going to get the max value between the two of them. Because in what game ever does your quest progress go backward? If you're making specifically a game in which your quest progress can go backward in some cases, and this is not just for a quest as a whole, this is for specifically like each objective to itself, you're very unlikely to make something where you can like gather some stuff and then suddenly have less progress than you did before, right? Progress in a quest, in an objective, usually only moves forward. So just getting the maximum value between what you have saved and what you have in memory currently should make sure that it doesn't get overwritten due to any like weird stuff, due to like proxy quest actors or whatever. So that is the reason that we do that. Now, if we have done this and we've gone through this entire for each loop, and that means that we have found a exact match for our actor, we can just return to save ourselves going through the rest of this for each loop, and more importantly, through the rest of this for each loop. However, if we reach the end of this first for each loop without ever getting to the quest that we're checking for, that means that we just don't have information on that quest in our save list yet. So in that case, we can just get our active quests and we can add unique. Very likely, you can also just use add instead of add unique. It probably will be fine. I like just doing add unique, and we'll just add the input data from that. So now it will add it to the list because clearly we don't have anything to update. We just need to add some new stuff. Then going back into add to active quests, making sure that these two things are hooked up. That is the next little bit done. So we can fairly easily now off of our save object to active quests. This array goes into that array, and now this event is done as well. It was quite a little bit of a headache, but it is finished now. Which leaves us with only one more event to make in the game instance, and that will be a custom event again, and we'll call that get quest data. And this one is quite long as well, but it's fairly straightforward. So what we're going to do first and foremost is get all actors of a specific class. And the actors that we're going to be getting will be anything that is a base quest. Now, anybody familiar with the actors of all class node knows that this is also fairly expensive to run. So this is another one of those things. This is going to run one time at begin play, and then you're going to leave it alone because you don't want to be doing this constantly. Let's do a for each loop over that array though. And here we just get our quest save data. And from there, we get our completed quests. And since we're iterating over the individual quests, we can just get the ID from each one of them and check whether or not it is contained within the completed quests. Because if it is, we don't need to do anything too complicated. We just know, hey, this quest is completed. We can just add it to our completed list and just leave it alone. So let's do that. We add in a branching node for that logic. We do technically want to start the quest so that it initiates all the objectives. That way you can still see the objectives in your finished quest list view, but it's not going to like give you the rewards again or anything. And then we want to, much like before, use a quest component input here. So let's make this, oh, it still is on quest component. That's fantastic. Quest components. And we just use that to get the finished quests and add to that the name of the quest ID from our current iteration of the for each loop, together with the object from that for each loop iteration. And we just hook that up like this. That is dealing with finished quests. Now let's deal with quests that have been started but not yet finished, because as the theme is with this video, that is where the headaches come in. kind of. We've had the worst headaches behind us. Let's make a copy here of the save quest reference, and we get the active quests, for which we're going to nobody's surprise, for each loop, and we'll hook that up to the full spin of this condition. Here, we're going to check with a break if the quest ID that we have here is equal to any, again, exactly equal with 3 equal signs, to any of the quest IDs that we have in our active quest list. Because if so, that is where we actually activate and add the quest to our quest component. So if that is true, we get our quest component reference again, which is going to be very noodly all over the place, but I like that. And we add a quest, and the quest that we'll add will be the element from this for each loop. And we hook that up to the true side of that branch. Now, we've added the quest to our in-progress quests. Now we need to go back into the base quest real quick to add in a new function, because we made this get completion objective progress, but we also need one to set it now. But that's going to be so much easier, because what we can just do is we can just set completion objective progress, and we just get our objectives, which already I think has a set objective complete by ID, which is still entirely based on arrays again. So we need to go into there, and instead of using this with an array, we're going to be changing this to a map with float values. And for the basic one, it's actually relatively simple. We get rid of all this. We just find the objective ID in the map that we deliver in. We first check whether or not that find was successful to begin with, just as a little bit of a security check. And then we check whether or not the completion progress is greater than or equal to 1. And then we just set our is complete to the output of that. We're not doing the on completion finish objective function here, because that calls out this delegate, and it can be a little bit bothersome because you might have things listening out for it that like update things, and that might accidentally finish parts of the quest that might have rewards tied to them or whatever. If you are building this out in a more complex and complete way, that can be annoying. So in this case, we're actually just going to set this value directly. Oh yeah, and then we want to make sure that we're comparing this to be greater than or equal to 1, not 0, because otherwise it's always going to be true. Then, as always, we need to go into the objective collection and overwrite the version that that has as well. So we can set objective complete by ID. And this one is slightly more complicated, but not by that much. So let's do this. What we're going to do is we get the sub-objectives, and we'll for each loop over those. And for all of these, we're going to just kind of call the same function. So we set objectives complete by ID, and we just forward in the map that we're getting given in here. Do make sure to hook these two up, otherwise it's going to try to call this function within this function on this object itself, and that creates an infinite loop. So make sure that this node is hooked up to the for each loop. Then for each one of these, we also get the completion progress, which gets us those two floats that we can use. In this one, we only really care about the clamped version. We don't really care about the unclamped version of anything. So what we do is we just make a quick local variable, total progress, and we just set that to being total progress plus the unclamped completion rate for each iteration in this loop. And then on completed, we just set is complete in much the same way that we did before, directly hard-coded, not through a function that has like a delegate to it, because we don't want to do that. And we get this total progress, simply divide that by the length of our sub-objectives array to normalize it to a 0 to 1 range. And then we just check whether or not that is greater or equal to 1 to set our is complete state. So now back in the base quest, we have this set completion objective progress, which is going to just take in this map. So most of these functions are just taking in the map and forwarding them to an object that actually knows how to deal with them. That is mostly what is going on here. So in the quest game instance now, what we can do is we can use the array element from this for each loop in the quest data event. And we can use it to set completion objective progress. And we do that by providing in the broken data from our getActiveQuests thing here into there. Now that's all the system code in place for allowing us to update and get the information and save and load it to save slots. Now we just need to make a quick actor that allows us to go between levels and add a little bit of extra code to our quest component to actually make this work. But saving and loading itself already works. We can just make a menu, and every time we want to load the data, we can load it from disk, and when we want to save the data, we first update the quest data and then save it to slot. So, matter of fact, if you're going to save quest data, you probably want to just update quest data first and provide in that quest component as a reference as well. So all of this will now work. So let's just, for demonstrational purposes, so let's make that extra actor real quick to show you going between levels. I'm just gonna do this properly right away. Level loading zone or something like that. Let's do a box collider. Can set that to being like somewhat larger. And then on begin overlap, we just cast to third person character to check whether or not the thing overlapping is a third person character, hence a player. And then we also get the game instance, which we cast to our quest game instance, from which we can just call update quest data, which needs to be given in a quest component. But hey, we already have a reference to our third person character, so we can just get our quest component from that and provide it in there. After we do that, we can just open level by object reference. Why not? We can just promote that to a variable as well. I don't know if that works in Blueprint, to be 100% honest, but I think it should. And then in our quest component, we go back into the event graph in begin play. We already like make a quick little widget here. But in this now, we get the game instance as well, which we of course cast to our quest game instance, which we then use to get the quest data, which requires in a quest component, but we're in the quest component, so we can just provide a reference to ourselves, make sure everything's hooked up with the execution pins. I always forget that. And after we get the quest data, we're just going to hard refresh the quest UI because we have gone out of our way to not call any event dispatches or any of that kind of stuff while reloading a bunch of data, because that can slow things down and maybe be unwanted in a lot of cases because it can trigger like weirdness. So we've been avoiding that. We're just going to update the quest list just explicitly here. Also helps that it's not running the update quest list like 1,000 times within one frame, because we are avoiding all those event dispatches in the code that we just wrote. So that's another reason to avoid that. So that effectively should allow me to move between two different levels now. So let's real quick make a second level to test this in, because I don't think I have one. Yeah, I don't. So I think that's in File, New Level. Let's just do a basic level. And in here, so if we take in, for instance, our kill quest, which actually I don't think I gave a quest ID, which is quite important. So let's go quest ID. Yeah, let's give it killing as a default value. And then just plug that right in here. You'll see that it has target 1 and target 2, which aren't filled in. We're going to see if that's a problem in a moment, because I don't know if it will be. Let's go into the level blueprint, where we just make a reference to it real quick. And then we make a trigger box around it. That's going to be like relatively large, something like this. Then we add an event trigger for that. Overlap. Other actor we cast to third person character. You know the gist by now. We get the quest components and we add this quest. So the wonderful thing is we'll be able to add this quest now in here, but we won't complete it in here. Now, we'll complete it in the other level, obviously. So after we pick that up, let's do our level loading zone, which is right over here. And that's going to load the third person map. And now you'll see I can run in here and I get my quest, but it's not bound to anything actually like in here. If I put some items in here, it will work, of course. Those aren't really bound to specific items. Those are just bound to stuff that happens in my inventory. But the enemy killing, for instance, the objects just don't exist here, so I can't complete them here. But if I keep on moving to my loading zone over here, you'll see that I don't need to pick up the quest here to actually have it unlocked already, because it carried over the fact that my quest is unlocked from the other map. Now, if I kill one of these things, you'll see that it completes it here. It has the next thing already completed as well. Let's pick up a couple of the items that we have over here. And now I actually don't have a way to go back to the other level. Hold on. I will be back in a moment. Just going to put down a level loading zone in here that links back to the untitled level. which actually allows me to show that it works the other way around as well. So I can pick up my second quest here, and I can kill one of these, which spawns the other one in over there. And I can pick up like some of the items from this quest, and then when I move over to this loading zone, it still has all that progress saved within here. It doesn't quite yet for these, because we haven't implemented that logic yet, but we'll do that in a moment. And then when I go through again, I can't pick up the quest a second time, just like always. It will still have all that progress. Now, it doesn't quite like trigger all the code for setting up the next activation quite perfectly. And that is because we are skipping over all the finish objective event dispatches. So just using finish objective here, if this is greater than or equal to 1, is an easier way to get around that issue. If it creates other issues though, you might need to create some code that explicitly activates the first objective that's next up in the list. Kind of depends on what issues you run into at this point, honestly. For now though, instead of doing this direct setting for is complete, I think just doing finish objective. It's not ideal because again, it's also going to be updating the UI like very rapidly a lot. So I would personally try to avoid this, but maybe that can be a video in the future. Because now you will see I can kill this one, and then when I next get back, this one still exists, but it already also spawned in that one. Am I talking out of my ass? So at this point, it's a little like patching up of issues here and there, of course. So we can go into the specific killing objective that we set up at some point. And here we can also make sure that when we finish the objective, we get the enemy ref. We check if it is valid, just to be sure. Because if it has already been destroyed, we don't want to try it again. But if it is not yet destroyed, we can just like explicitly destroy it like this. And that way, when we come back, it will automatically instantly destroy any of the objectives that have already been finished off for any killing quests. You need to do this for every single objective type that it is relevant to, of course. But you only need to set it up once, and then you can use the objective over and over and over again. So you can see no sphere over there, but it is still over there. Now, the last thing, and also you maybe want to add in an is valid on this one as well. For anything that you potentially like destroy and then read, putting an is valid in between is good. The last thing is setting and maintaining the progress on the item completion quests. So let's go into our item gathering objective. And the main thing here is just to override the function for set objective complete by ID. Because what we're going to do here, we can just do the parent function as well if we want to, because this just takes care of setting it to being either completed or uncompleted. But what we want to do in this one is we then also want to set our information based on this. So we find our ID, so get objective ID. And then what we do is we just set the amount gathered to the amount to get, multiplied by this completion percentage that we're given in. And that should always return an integer anyway. So, and that should take care of all of that. So let's pick up the quests and let's pick up some of these items for a little bit of progress. Not all of them, because I want to specifically keep track of whether or not it keeps track of partially completed objectives. And now it does. So when we go back, we can keep on going with completing this quest where we left off. And the wonderful thing is, at this point, if we go back into the untitled map, we can add in a couple of item pickups along the way here. And since we're not binding to any specific items to pick up, what we can do is we can set this up to be like item 1 and have a couple of them in here. We can start a quest and actually gain a little bit of progress in this map. And that progress will carry over, and then we can gain a little bit of progress over in this map. Then we can go back to the other map again, and the progress will carry over. And we can even straight up like finish that part of the quest in this part right here. And then we can go over to right here, where we see, hey, get grass is finished. So completion of quests also now carries over, which means that we effectively have everything that we need for an entire full quest system. If you want the finished projects, as always, there's a link down below in the description for YouTube members and patrons to get the finished projects, mostly intended for educational purposes. But hey, if you just want to like pick it and put it in your own project, that's fine too. And it, of course, also massively supports me and the channel in making more of this type of content. So thank you everybody for watching. And those of you who are directly supporting me, thank you doubly so. And I will be back next time with some newly invented stuff. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Digger tier supporters, Sir J. Thomas,